I'm Jim Bednar. I sort of manage the PyViz project that you'll be hearing about. Jean-Luc is one of 3 people who do all the real work. He's expert in many areas of it. He'll be helping you with installation problems during the first part of the tutorial. That's what it always is going to be. And then after that, with any actual questions about PyViz or the topics we cover. So the expectation is usually that during the first hour, 45 minutes or so, I'm going to present material that doesn't matter whether your laptop is working, and during that time, you're going to get visited until everything works, okay? So,
1, 2, 1, 2. We have a handheld here if you want to walk around.
Okay, thanks.
Just click it on with your second.
So when I do a conda update, it's telling me that 195 is the latest HoloViews.
Conda, you need C PyViz right here. So there is the latest HoloViews on the defaults channel is always behind. That's up to Anaconda as a company, and PyViz is up to us. So when you install anything, install it from you need -C PyViz.
Do you update in CondaForge?
Certain parts of the things in PyViz are updated on CondaForge, but for this tutorial, we're not using anything from CondaForge. It's all from defaults or the PyViz channel. If you want to use CondaForge, you can, but you have to be very careful not to mix any packages between CondaForge and defaults that have binary interfaces that might matter whether it was compiled the way defaults does it or the way CondaForge does it. It's very tricky, and to avoid that, we do not list CondaForge in anything we're doing here. This is the easy case. If you want to use CondaForge, it's fine. You just have to make sure don't use it. Make sure you always have specified CondaForge every time you install something. Then it's fine. But you have to be in one world or the other. For this tutorial, we're not in CondaForge world. We're in defaults world. And hopefully, I'm trying to get people together at this conference to look at each other and agree on how to compile, because basically you just have to set the compilation flags exactly the same, and then you're binary compatible. They're different. They're different compilers, different versions, different flags. You can't mix and match. So you need to make sure follow these. So I highly recommend making this new environment here so you're independent of whatever else you're doing. Okay, does anyone else need the Post-it notes to indicate your status? We're baldly copying this idea from software carpentry. And it seems useful. If you have one of each color, if you put a green one, it indicates you've got it installed and running and you're happy. If you have a red one, it means you're having trouble. If you have anything else, you're working on it. And if you don't have Post-it notes, just raise your hand. Jean-Luc can give them to you. Yes? Oh, you're just waiting for the notes. Yeah. Sorry, I was a professor for 10 years. I'm going to call on you. Okay, I think I'll go ahead and get started with the introduction. Is this level of microphone okay? Okay. So, for the purpose of this tutorial, you should start with the special index page that we put together for SciPy. Well, you'll be presented, once you launch the software, you'll get something like this. Actually, you'll get the previous. You'll get something like this once you launch Jupyter Notebook. So if you have green on your laptop, I would expect that after running Jupyter Notebook, you've got something like this. If you have Windows and you haven't told it to use a decent browser by default, you may have to cut and paste from the place where you started, wherever you ran the command, Jupyter Notebook, it's going to print the URL. You may have to cut and paste that into whatever browser you're actually running if you haven't told the system that you don't like Internet Explorer. I don't recommend you run any of this on Internet Explorer, so just don't do it. It does work in certain cases. It is possible, but it's just not worth it. So run it on Firefox or Chrome. Safari probably works. We have not tested this on Safari. At some point in the past, it has been tested. So you should be getting a friendly and helpful and mysterious page like this. You just click on Notebooks. And then there's a special index here down called SciPy 18. That's the one that we're going to follow during this tutorial. If you go online, you can get to the SciPy 18 page, but the main index is slightly different. Basically, this is a day's worth of material, even with me leading it, let alone self-paced. So we've designated certain sections that we're going to skim. And so these are all there. We'll show you what's there. We'll make you you know what's available, but we won't step you through it. Otherwise, this would total up to a day worth of material. Okay, so this is the index that covers everything. I guess to start with, just some background. How many people here use Python? Okay, it's a good start. How many people here use pandas? How many people here use pandas plotting, pandas.plot? Okay, how many people use Matplotlib? Okay, how many people use Plotly? How many people use something else to do plotting? Not many. Okay, well, I'll present a slide that's interesting in that context of that answer with only 3 people saying something else. That's interesting. All right. Okay, so the idea here is that we're going to present a certain set of packages, and we're going to tell you all about how to use them. And I guess we'll come back to this schedule in a minute, but let's go ahead and start. Everyone who has it running should probably run this tutorial 0 setup. That's part of getting your green sticker here. So if it all works, it should look like this. It should tell you you have this version. Someone just ran and found you got 1.9.5. That's not going to run this material because we're showing off some of the features that have been added more recently. And these will make sure that you have the data sets installed. Okay. All right, so for the first part of this tutorial, as I said, what I'm going to do is give you an overview and introduction to some basic concepts, see what's possible, and then in each of the later sections of the tutorial, we're going to drill down in certain topics and show you really how to do it. So in this part, don't worry if you don't catch, oh, how did he do that? We'll come back to it. This is meant to be an overview, and so you get a whole idea of what's going to be there, and then we'll go step by step through the sections of it. And the whole motivation for PyViz is to try to make visualization not be a nightmare. There are many online posts. If you just search for, if you search for Python visualization nightmare, you'll find posts. But certainly if you search for Python visualization, you'll find a lot of unhappy people. And in my opinion, actually making progress in science and analytics in general, it should just be easy to visualize things. It shouldn't be hard. There's nothing inherently difficult about it. And we're focusing on the idea that you have some sort of data, and eventually you need something to happen. You have some data that's relevant to you in some way. Maybe you started with a question, maybe you started with the data. So maybe these first 2 bullet points could be flipped here. Maybe it's interesting data and that prompts a question, or maybe you have a question and you get data. Either way, we're going to focus on exploring the data and that's a highly visual thing if you do it the way we're recommending. And then potentially modeling the data, in which case you need to visualize what the output of your model is. And then communicate. You need to be able to share it with somebody else, and often that is visualization as well. So basically all the last three stages here are highly visualizable, highly visualization based, but a lot of people postpone the visualization because it's hard, it's annoying, it's like you have to write a lot of code or do a lot of manual steps. I'll do that later. And one of the things that I do, I work at Anaconda, as does Jean-Luc, who's going around helping you, and as do most of the people involved in PyViz. And we work with corporate and government clients who have problems. They come to us, they have problems, they want to use Python to solve them, and often they have imagined a solution. It turns out that because we're visualization experts, every time we work with them, the answer to it is visualization. They think they have a machine learning problem. They don't have a machine learning problem because we show, well, actually, your decision boundary is just right here. You can just see it right here in this picture. You just do this in this case, this in this case. You don't need to train some fancy model. It's just obvious. It's right in front of you. Oh, your bug. Look, there's your bug right there. You don't need to do anything. So obviously, if you came in with a different background and tried to make the problem fit your background, you have a similar thing. But anyway, that's our background. So we're trying to make it be everything you do all the time should be super easy to visualize. And is that currently the case? It is for us. It can be for you. But instead, this is what you get. This is Jake's beautiful picture here, which is interesting in the context of people use Matplotlib, a little bit of Plotly. How many people use Bokeh? I forgot to ask. Okay, a few use Bokeh, a few use something else. There's a ton of stuff out there, all of which is in some way, nearly all of which was designed to make up for some deficiency of Matplotlib. Matplotlib did something, and it's been doing it for a decade. It's been doing it for a very long time. Matplotlib is the reason that I am using Python. Back in 2002, we were trying to decide which language we're going to use. There was no good plotting library. Suddenly, there was Matplotlib. It's like, oh, okay, we can use Python. We will not use Scheme for all our work. So that would have been a nightmare had my life gone down that path. But the presence of Matplotlib was crucial for Python being taken seriously as a data analysis platform. But it did what it did, it does what it does, and there are lots of other approaches to do things that it doesn't do, such as deep interactivity or 3D visualizations, things that are based on, so these three are 3D, this is 3D, I'm sure there are others. Things that are very good in web browsers, so things that are based around a JavaScript library, either built in JavaScript themselves or built around an existing JavaScript library outside of Python. And then, of course, things that are built on top of Matplotlib to add new features and make it easier to use sometimes. But if you're a user, you just look at this and you just think, I don't know what to do, I'm going to use Matplotlib. Because all the web is going to tell you to do that. Everywhere you can find, every problem that could ever be had with Matplotlib has been had by somebody, it's not you. So you can find that and you can find the solution to it. So basically the world can struggle and be miserable, but it's okay. But we don't want that to be okay. We want it to be easy. We want it to be fun and nice. So we're working hard to change that. What we did is identified a subset of the packages here, and we said, okay, we're going to say, we can't do everything. Number one, we don't do 3D. Well, we do a tiny little bit of 3D exactly as necessary, but almost no 3D. And so that cuts a lot of things out. And we also wanted things that work well in web browsers, therefore, that are highly interactive, but where Python is not a second-class citizen. And a lot of the things that are built around some of the existing JavaScript libraries, they look great, but they don't go very deep because the JavaScript development happens over here and you have a rough exposure of some parts of it into Python, but it's not full and deep. And if you're working in Python, you're a second-class citizen. You're not a true user of that library. So we focused on ones where that was not true. Bokeh in particular is written from the ground up in JavaScript, but JavaScript in service of Python, not JavaScript being papered over and wrapped up. So we identified this subset and said, okay, we're going to try to make it easy to use Matplotlib, which is normally those sentences, that sentence could never exist, right? Easy in Matplotlib, no. Reliable, yes. Long-standing, venerable. Easy, no. And certainly not easy and powerful in the same sentence. But yes, we offer you that. We're going to try to make it not matter a lot whether you're doing geographic or non-geographic data. And those communities have been split for, the geoplotting community has been working on the same tools for decades. These legacy tools in many different languages are patched together to present a processing framework for geodata that's fairly hard to get it all work together. But it's important because often data is situated in the real world. You want to show that. So we want to make that easy. Data shader here we'll talk about allows you to deal with the fact that if it's JavaScript, it's running in your browser. And if it's running in your browser, there's very little memory. And so you can't handle very large data sets. Data shader addresses that because we want everything to be in the browser because we want to focus on this last step here of communication. We want to make sure that as soon as you see a visualization, you can share it immediately, and there's no problem with that. So, okay, so that was our goal, and we are being supported nominally by Anaconda, but largely by external companies and government agencies that have contracts with us. So the very vast portion of the budget, which is, I don't know if I'm allowed to say it, $1 million a year or so, I guess. Actually, that's a rough guess. I haven't totaled it. But it's a substantial amount of funding from basically a series, that's in total across a variety of different funders. And these are people who say, oh, this almost solves our problem. Almost, but I need this. Okay. Well, that's all free. You pay for that. And you say that to everyone in turn. So we've had a series of different agencies and companies paying us to make this come together for them. And so that also will explain some holes. 3D, for instance. Nobody has wanted to pay us for 3D. We didn't need 3D. We don't have 3D. Simple as that. There's no fundamental reason that we can't have it. It's just that it's historically been different sets of tools that handle 3D and non-3D. Okay, so to dive into it, most people said that they have, nearly everybody's tried pandas. So let's assume you're starting there. Let's say you've read, oh, I haven't run it. Guess I ought to run it. Okay, so go back to where it was. There we go. Now we have an actual result. Okay, so we've loaded a pandas data frame. In this case, this happens to be one containing disease incidence. So it's counts per 100,000 people of people who got various diseases. And as you can see, this is a tabular data set. Data is arranged in columns. It's not a very tidy data set. You have week 1 of 1928, week 2. It's a bit of an odd structure, but it is all arranged in columns, so we can deal with it. So immediately, let's just do what pandas suggests. Let's do dataframe.plot and say, okay, it should be easy, right? That plotting should be easy. So let's see what happens when you do something easy. You get this plot. This plot indicates that data was collected from a certain range in the past to the present, and that it's arranged in that order in the file. So this is not a very useful plot, right? You can't really do anything with this. So we actually have to use some thinking. Unfortunately, we can't just have the magic plotter. And that comes back to the way this data was organized. Had it been organized in a way to support plotting, which it was not, you could magically plot it. So let's reorganize it. If you know enough pandas, and I'm just going to assume you know pandas for the purposes of this portion of the tutorial, So let's, for instance, group it by year so that you see how it's got year, week. Basically, it's got a bunch of observations across different weeks in the year. Let's collapse those per year so that it doesn't do weird things. And then let's, so we're grouping that by year. And then let's plot the overall incidence of measles across all the states. This has data per US state. Let's aggregate that, ignore the state information, and just get a single plot out of that. So if we have by year, you can see what that is. By year is basically year and measles incidence. Make sense? This is nice, straightforward data now, designed for plotting, and you get a plot out of it right away. And if you actually care about the underlying data, this particular one is showing that measles was a thing that happened to a whole lot of people until right around here, which is, and if you go to Wikipedia, you can find out that in 1963 there was a vaccine for measles. Like, okay, that vaccine seemed to have worked. Okay, all right, data, real world, and they're related to each other. Great. However, if you look at this, what have you gotten? You drag this around. This is an image. This actually is, you can save the image. This is a PNG. That's what you got out of it. That's what Matplotlib inline is going to do. Turn your Matplotlib plot into a PNG. This is running in a Jupyter Notebook right now, and so it's going to allow the Jupyter Notebook to use its rich display to show you the image immediately. And you can do nothing with that image other than look at it or save it to disk. First off, we say, okay, well, that was pretty easy. Can we set up our tools in a way that will allow it to be that easy, but now you can actually do something with it? So here's the first demonstration of a PyViz tool. This is a new project, and it's actually quite brand new, and it's I haven't gotten entirely comfortable with it because it's basically what this project is called HVplot, newly released. It is an implementation of the pandas API for plotting, but implemented on the PyViz tools. So you can do exactly the same thing for this simple case, but also for quite complex cases. It's a quite complete implementation of the pandas plotting API. So if you already know that, just before you do the plotting, type this in, import hvplot.pandas, and then when you do .plot, instead do .hvplot. And if you do that, you get a plot that looks the same. But the difference is that because this is actually a plot generated by Bokeh, it's an interactive plot, which means that you can hover over it, you can zoom, you can set up to look at some particular region of the data, whatever it is, so you can find out the numerical values and so on. So this is now for the same API cost as the previous plot where you get an image, you get something that you can use to explore the data. And the advantage there is if you just get an image, if the image isn't right, you have to go back and edit your code. Here, if the image isn't right, I only care about the region right down here, and I want to zoom in there and really see what's happening after the vaccine is introduced. You don't have to go back to your code and try to think about it and relate the numbers you saw with the code. You can always do that, but it's pain. You're trying to actually explore, and you want to have as little as possible between your data and your brain. You want to just be able to explore it without having to write code. Being able to write code is great. Being able to customize it is great. Having to write it every instant is often much slower than other things. Okay, so that's the first thing you get. As you might guess by this .pandas, pandas is not the only thing hvplot supports. It also, you can import hvplot.xarray, and it'll be able to plot anything in xarray using the same interface. hvplot.streams will handle streaming data from the streams library. There are 3 or 4 others that are supported. So hvplot is designed to give a pandas-style plotting interface to any data package. So I think there are 6 data packages supported so far. So we're going to, for this talk, for this section, I'm going to be focusing on hvplot. And that's, so if you could take away nothing from the talk, if you've got to go to the bathroom and you just bail for the day, you will have seen hvplot.pandas, and you'll know that I'm looking at my pandas plot. Just a few characters. You can type that, you can start to interact in the browser, things you couldn't do before. Okay, so you'll have something to take away. But that is nowhere near the goal that we want to get to, so let's show you that in a second here. But it is at least one way in which we're designing plots that are not dead ends. What this plot is here is this particular, let's just print this. This is not an image or a plot in any way. What this is a declarative object that when Jupyter goes to try to display it, there is a way to display it as a plot. But this is actually your data. It's kind of weird. So what you get with hvplot is not an image at all. It is a thin wrapper around your data that declares certain things about your data, which is that it should be plotted as a curve with year on the x-axis and measles on the y-axis. So this is a declarative way to say that you have data in your pandas data frame, and now it is data that is visualizable, but it is still your data. And why is that important? Like, why do you care what's under it? I just want to see my picture, right? Give me my pretty picture back. Okay, so there's your picture. But the thing is that now, since this object is not just an image, it has your data, you can do lots with it. Not just zoom and click. You can lay it out, you can add things together, you can overlay things, you can slice them, you can sample them, you can fiddle with the options until you like it, you can bring certain things out, subtract certain things, and so on. So we'll just show you a series of those. Here's an example of something, starting out, I guess, with something. I think I skipped one. I did. Let me go back to the underlying sorry. Somehow that has been reverted. So, didn't need the home page. Go back to our slideshow. Okay, so what you got here is from a library called HoloViews. So hvplot, the HV stands for HoloViews. HoloViews is a library for wrapping up data in a nice little chunk with declarative information that allows it to be visualized, but also allows it to do all these other things, slicing and dicing and sampling and so on. And so in this case, back to our actual view. Okay, so in this case, for instance, let's say you noticed on that day when you were looking at that data that it was 1963 and you looked it up in Wikipedia and you don't want to forget that, which having had children, my brain doesn't work anymore. I can have an experience and then I can have the same experience the next day and the next day. Oh, look at that, that's where the vaccine was, and I can keep doing that. But with HoloViews, because you've preserved the data, you can actually build up things that capture your understanding and preserve them and eventually communicate them. But first off, they capture it just right there in the notebook while you're working on it. And in this case, this is what we were just looking at that I showed you was not an image and not a plot. It was actually an object you can do something with. Here's one of the things you can do with it, which is to take it, overlay a vertical line on it. In this case, it's a vertical line at 1963, which is when the vaccine was introduced. We can overlay some text on it to say that was where the vaccine was introduced. And then these little stars here mean to overlay. That means take this, overlay with this, overlay with this, and then the result is still not a plot, it's still just an object. In this case, it's a declarative object that has some hierarchy, and we'll get back to that. But it's still something it displays, and what it displays is the plot with this overlaid information. Does that make sense? By the way, I'm loving all the green stickers I see everywhere. It's very reassuring. So I won't have to just talk up here forever. Okay, so here was using the plot API for pandas. So that's where we got this object. But it doesn't matter how you got that object. If it's a HoloViews object, you can combine it in other ways with other HoloViews objects. In this case, we're making HoloViews objects explicitly. Import HoloViews as HV, HV line. Could be, we could make a HV.h line. It's going to be crazy, but. Need one more star, though. And so on. You can have as many objects as you want. You can have other data sets, whatever you want to show. In particular, so the idea of this is that it's captured your understanding. The next slide was trying to be a little more ambitious, which is to say, okay, well, I'm going to try to massage this data and work with it a little bit. Let's take our data frame and let's group it by year and state. And we're going to plot measles again. So we're basically, instead of aggregating over state and collapsing all the state information, let's preserve that state information because we want to see how it differs per state, let's say. So if we do that, if you did the f.plot, I have no idea what's going to happen. It's still useless. Oh, it's still but measles eggs might be better. I doubt it. Okay, well that gets you something. That gives you a plot by year and state. So all the states are overlaid together. Okay, that's not particularly useful. What does HoloViews do with this? Instead, what HoloViews does, if you ask it to do HV plot of a year, you can tell it to group by the state. And once you group by the state, you haven't indicated anything that should happen to the state. The state isn't on the x-axis, it's not on the y-axis, it's not collapsed, nothing happened to the state. So where's this state dimension going to go? Well, with HoloViews, if you have a dimension and doesn't, independent dimension, and you haven't told it what to do with it, it gives a widget because the user has to tell it. Basically, HoloViews is declarative. It's saying all sorts of things about the data set, and one of the things it knows is that it has to know the state before it can plot it. You saw what pandas did. It crammed all the states on there. It said, okay, you want the states? They're the states. They're all in one plot. What HoloViews does is say, you want the states? Which state? What state do you want? You can do other things with the state information, but by default, if you haven't told it what to do with something, you're going to get a widget out to the right that asks the user, what do you want to do with it? So in this case, you just select whatever state you want, and then it's still the interactive plot you could always have. But it has this automatic thing that comes up, and this is super good when you're exploring a data set. The idea is to make it very quickly obvious to you that, oh, you're right, I didn't tell it what to do with the state. Or maybe you wanted this widget. Either way, it's great. Either it's there and you know, oh, well, I guess I better pick a state. Maybe I want to collapse across states. Immediately you can see you need to do that. So if you want to, like I said, it was indexable, sampleable, sliceable. So in this case, let's just pull out Texas and compare it to New York. When this plus operator lays things out side by side, and when things are laid out side by side and have the same dimensions, it will normalize them together. So you'll see that New York isn't going all the way to the top because it's the same dimension. Again, it's declarative, so it knows that in this plot, this is the measles axis, and this other plot is also the measles axis. And therefore, if you're showing them together, they better match up. Yes?
The y-axis are the same scale on those. Is that always the case?
The same scale.
Yeah, like 800 and 800 are the same place.
They are in this case because they are linked. So if I were to choose Connecticut, no, I don't know how to spell Connecticut. Rhode Island. It's relabeled New York, but you'll see that now it's a different scale. So it's auto-ranging to the max, but they're normalized to have the same range. And that's what I was saying, that because they're both measles, if one of them was measles and the other one's pertussis, they wouldn't be normalized together. But because they are the same axis, you can make it not normalized together, but by default, if you're putting them in the same figure, HoloViews assumes that you meant them to be compared to each other. Yes?
What if I wanted them to be vertical instead of horizontal?
Layout is one of the things we have been paid a lot of money to work on and have not done anything about. We will. We haven't used up the money yet. But in this case, we can do that. So basically, things are laid out left to right up to a certain number of columns, and you can tell at that number of columns whether you want one column. What we don't have is hierarchical subsetting of, you can pack 3 vertical things next to 3 vertical things next to that. We've shown it, but we've never been happy with the API, and we can't get everyone to agree, but we're being paid to agree, so we're going to agree on that. So in any case, the plus indicates not side by side. Sorry, it indicates side by side as in not overlapping. It doesn't indicate exactly where they are on the page. That would be a different type of hint. So there could be another system on top of this that controls hinting on the final location. What it does mean is they are not overlaid, yet they are in the same figure. And that information is enough to know how to do the scaling of the axes. And that's the whole design of everything I'm going to talk to you about. All HoloViews is designed to, can we get the information we need? Okay, I don't need to do any more. I know, I'm going to do it. So it's designed to make use of the information that has been declared, not make any assumptions, not make any unwarranted assuming that it's a certain way, but whenever it has been declared that it's a certain way, there's lots of implications of that, and it implements those implications. The vertical axis label, good question. I think probably because we relabeled, yeah, I don't know. There's no, oh, in this case, it's gone because it's part of the entire figure. I think that if they were two different things, they would have an axis label just to distinguish them. Otherwise, you can put it in the label of the figure what it is. I'm not totally certain because this is HVplot that is doing this right now, and I'm used to using HoloViews by itself, and I deeply know the behavior of that. HVplot is newer, so I can't answer that question right away. So here, all we did is add a, remember if we didn't have anything special, we were going to, oh, this has already been sub-selected, sorry. In this case, let's tell it to, if we do this group by, we would get, this is what I showed you a minute ago. There's a variant of it that does takes the fact that it was that does one step further. It's basically group by plus overlaying. It's just a shorthand for by. It's kind of a shortcut. So if you just tell it by state, it'll cram it all together. That probably isn't necessarily what you wanted. Maybe you wanted to see all separated out. In which case, in HVplot. Again, I'm very familiar with the HoloViews interface for this. In HVplot, it's trying to follow the pandas interface. So here you'll specify that you want it to be state no longer to be a widget, you want it to be a column, which is kind of a row. Oh, the column is state. There's a column per state in this case. So there's a California column, a New Jersey column, a New York column, and a Texas column. So basically, you can explore the data however you feel like. Oh, and notice the one thing here is that we overlaid the vertical line. Because those were all the same type of plot and had the same, the x-axis was the same, it's meaningful to put the line on everything. And it just does that automatically. Because you're putting a vertical line on an entire object here, which is, you can see what the representation of that object is. It is a grid space indexed by state of items that themselves are curves, indexed by year, and providing measles information. Does this make sense? So this is just a convenient way to understand the dimensions that are involved here. A grid space is literally a space that is laid out on a grid. This is a one-dimensional grid, but it can be a two-dimensional grid. This data doesn't have the other dimension. And so that whole object here, if we overlay it with a vertical line, you get another object. Hopefully you can start to see where these are going. Now it's a grid space of overlays of curves with the vertical line. Got it? And you see all these, this dot 1 here is just because you haven't named this vertical line. And in Python, you can't have a number as an identifier, so it's using Roman numerals. Jean-Luc did that, so blame him. I thought it ought to be item 1, but that's one choice. All right. Or you could, HV plot, you'll have to dive in. If you prefer, if you're comfortable and happy with the pandas plotting API, go to HVplot's website, which you should be able to find from, well, it's hvplot.pyviz.org. I don't know where you'll see that. But that'll take you through everything. So it should be the familiar interface you're used to. In this interface, if you don't want the default of a curve, you can switch to a bar. If you want to do that, then you end up with a bar chart. And, oh, and here, this is rotating the text. This is not how HoloViews does things, so you'll see that in a minute. Okay, if you want more complicated things, you can compute the error bars. Here, these are all, this entire talk is focused around the pandas way to do things. So here you're going to use pandas to do all your data munging, all your flipping things around. Here you're using pandas group by, pandas ag, numpy functions that you're giving to pandas, pandas function that pulls out the x's in the plot, and you're using the HV plot to turn that into something visualizable. And then over here, this is the HoloViews interface, which is to explicitly say what type of plot you want. And then you're passing in what you computed from pandas. And we won't spend much time on this, but this is basically how you tell it that error bars below 0 aren't useful, because the measles incidence was never below 0. So you can calculate an error bar that goes below 0, but it doesn't mean anything. So it's not doing anything useful, not doing anything terribly important other than avoiding having the plot look like that. Okay, and as always, we can overlay things, no problem. Okay, so this data actually, I don't know if anyone out there is savvy enough to recognize the data and where it's from. It's from a particular Wall Street Journal article. It's taking public data, but he was massaging it in a certain way. And if you want to replicate that plot, this is the code to do that. And this is a little more complicated code than we've been dealing with so far. But it's still, what this plot will have in it is 3 things. It'll have a heat map, which we haven't shown yet, but it'll be obvious. It'll have the same thing we just looked at, this error bar, and then it'll have a text marker. So I'll just show you the plot and then come back to it. This is the whole thing. It's a heat map on the top, plus an overlaid aggregate. So this aggregate here is basically everything above it collapsed. So it's collapsing across all states, and that gives an error bar. So in that year, how did the measles incidence vary? Well, some states had high measles, some states had low measles. This error bar shows you that variance across the states. The aggregate itself was a combination of the average and the error bars. And then we overlaid, so it's already an overlay. We also overlaid a marker on top of that, which is this guy. And we told that to be 900 pixels wide. And then we put it next to a heat map, and we told it to be 1 column. So then you get this whole thing where you can now hover over and find your favorite state and see during a particular year whether it had any measles and so on. And you can see that even accounting for the errors, no matter how you look at it, if you look at the colors in the heat map, if you look at the error bars here, if you look at the means, something happened in 1963 where that vaccine was introduced. Very quickly, measles became a thing of the past. So, and this was the original inspiration for looking at this data set. The code involved with the Wall Street Journal did not look like this. It was very complex in the original, but but they were working directly with JavaScript tools, I assume, because that's what they ended up with. But here, you can look back, having seen it, you can say, oh, that's kind of a complicated, messy plot. There's a lot going on, but basically it's a heat map, a mean with error bars, and a marker, and that's what you see here, the heat map, the mean, which is the ag, with some error bars overlaid. Here's the mean, which is what we got out of this aggregate operation, and then the error bars overlaid with that, and the text. So it's not anything crazy. We do have to set some options. We have to make sure to rotate the text. I haven't really discussed options, but here are all sorts of options. If we didn't have the colors be log, they wouldn't be very visible, and so on, but you can just fiddle with that however long you want to. You can change the, here it's turning the x-axis off because there was already an x-axis here. It's actually off the screen, but there is an x-axis there. Okay. All right, make sense? Just to get back to Matplotlib, remember I've said that HoloViews is a declarative library. HoloViews is not actually a plotting library. HVplot is maybe considered a plotting library. All of them are, but what HVplot does is give you HoloViews objects. What HoloViews objects are declarative data structures that can be visualized, but can be dived into, sampled, and whatever. And because of that, they don't actually know what plotting library you might use to plot them. In this case, let's take the same data and then tell HoloViews that we want to use the Matplotlib backend, not the Bokeh backend. And you can still get interactive plots. You can still work with it just fine. It's just that this little thing here is now an image. You can no longer zoom into that. We can still do all the same things, and you'll see that in the next tutorial, which is that anything that HoloViews has done is all the same. The things inside the plot, that's up to Bokeh. And Matplotlib just gives you an image. Bokeh gives you a rich plot, but you can use either one you want. And so particularly if you want to get SVG output for some fancy publication quality plot, you can start with HoloViews, end up with SVG from Matplotlib, publish that. And you can use the Bokeh one while you're exploring, and then switch to that for publication if you want to have a simpler thing that doesn't involve any JavaScript and is very straightforward to export. One more little example here before look at the last section, which is how many people have used Seaborn? So for a while, HoloViews had a Seaborn interface, but now what it's done is kind of subsume what's in Seaborn, and the reason for that is Bokeh, which is that you can now you can have Seaborn style plots from directly from HoloViews. In this case, it's via HVplot. You can get it either way, and that gives you the ability to have interactive exploration of the plots that would have been static in Seaborn. And so in Seaborn, you'd be going back and forth. It's not quite what I want, code. Not quite what I want, code, and go back and forth and spend a long time doing that. Here it's just, you want to see everything compared to everything, just dump it out and explore it and have fun. Okay. And this particular one, in Bokeh you have to enable different tools, but by default it enables a little selection tool that lets you track the same points across everything. And HoloViews knows that every one of these little plots are linked because they're all, well, not everyone. He knows which ones are linked because you can see that they're declaring their axes. So whenever you zoom, it's zooming only the ones that are that particular quantity. Okay, so that's the main part of this talk. Then there's one little pointer out of here. It's going to branch out in different directions, and then we'll move on to you try it out yourself. So that was just the standard out-of-the-box functionality. It's there for anything you want. If you want something special, PyViz is modular, And so you can bring in other packages for things you need. For instance, if you need geodata, you bring in the sister library to HoloViews called GeoViews. GeoViews is just like HoloViews in that it wraps up things and makes them easy to use, and also just like HoloViews that it does very little itself. It's just a friendly declarative interface on top of decades of work in the geoscience community. Right now you could be at the Cartopy tutorial. Yeah, a lot of what's in GeoViews is based on Cartopy, but it's presenting it with a HoloViews interface. So you'll see an example of that. Look at Data Shader very briefly, which is, yay, I'm using JavaScript and I'm putting things in the browser. Oh, my data's big. My browser just crashed. Data Shader deals with that. Param, if you saw that we had widgets, those weren't custom widgets. Those were automatically deduced by HoloViews. But what if you want a widget that just does the one thing you want it to do, or the 7 widgets to do the 7 things you want to do? You need a way to be able to customize that to really control and explore. So the param-related projects do that. And we don't spend any time on it, but we have a lot of perceptually uniform color maps for when you're dealing with large data, so it's not misleading. So, so let's, first we'll look at a larger data set. The ones you've had so far have been quite small data sets. This particular one is large-ish for us. It's 10 million points. I'll switch to 1 billion point one that I had running earlier. It'll probably have to swap back in though. But this is a 10 million point data set. This is just a subsampling of the standard New York City taxi data set. So all it does is show, in this case, GPS locations of pickups of taxis in New York City. But it illustrates what Data Shader does, which is, well, it also illustrates GeoViews. So here, GeoViews is easier to explain maybe. So here you have background of map tiles. This is all coming from an external server at Esri. We have nothing to do with this. We're just pointing to their server. And whenever we need to, it pulls map tiles, which is little chunks of images from their server, and puts it on the plot. And so if you want tiles behind your work, if it's situated in geographic coordinates, then you just, this came from GeoViews. There are about 10 different tile sources in there, and you can use anything that has a URL. You just pick one and then create a HoloViews object, and if it's a HoloViews object, you can overlay it. So that's what's in the background here. And then the foreground is something from Data Shader. This is our 10 million points overlaid on top of it. And this is being read from a file, and then we create a HoloViews points object. But if we were to, I'm not going to press return, but if I pressed return here, it would try to display this points object in the browser. And as soon as I press return here, it's going to say, okay, 10 million points. It's going to encode them as JSON. It's going to give them to the browser. It's going to feed them in, and somewhere about a third of the way through or a tenth of the way through, everything's going to die. So I'm not going to do that. I'm going to keep myself safe by erasing that. So all I did is I took that points object and I wrapped it in an operation. This is a dynamic operation, so it's not a function call. It's an object that repeatedly can be called whenever the plot needs to be updated. And this object will take this points data set and it'll turn it into an image. This is an image with alpha so that you can see through it. So wherever there's data, it basically counts the number of taxi points per pixel. And the brighter the color, the more taxi drop pickups there were in that location. And if there were 0, it's clear and you can see the background. So, and this is done per pixel so that when I zoom in, I can arbitrarily see all of the data as far as it goes. And so each time I let go of my mouse here, it's it's going through the 10 million points, rendering it into a fixed sized image that has been chosen to be the size of the viewport that I'm looking at, and then passing that to the browser. The 10 million points never go to the browser. But I can see all 10 million points, every one of them if I want to, just not at the same time. I'm always looking at aggregation of it. It's just that if I zoom in enough, I can see every individual little trip, including the ones that picked up in the middle of a building, which are presumably noise. But mostly they follow the streets. It's pretty good. I don't know New York, so I don't know if that's a stadium or whatever. It gets a lot of trips. You can also see that the data is quantized in some ways. You see how it's laid out in a little grid here? I don't know what that is. Something from the GPS data, or maybe just how it was packaged up as CSV. Didn't have enough digits, I don't know, but it's certainly quantized. And in most other ways of viewing the data, you'd never see things like that. You can see the total. You can't see differences between local regions. You have to really tweak it. Notice there's no special numbers here. The numbers are for changing the size of the image. And then here, this was determining at what point do I bottom out and just get a square that doesn't go and zoom any further. This number here is 0.5 meters. So this box is 0.5 meters in the world, in the real world on the map. And so it's saying don't zoom in closer than 0.5 meters, because if you don't, as you zoom in, your points disappear. So that's just a little hint to the visualization for you, but that's a choice that you can make as a user. You don't have to have any hints for how to handle the data. Data Shader knows how to handle it per pixel, and it knows how to map that onto colors in ways that makes things visible. And so you can just explore your data set. Okay, so basically okay, makes sense? All right, so the last thing to illustrate is to take that same example and add some widgets on it so that you can do custom things to control it the way you want to. And so we'll first show the widgets and then go backwards. So if you wanted to change things about it, this is the same example. You can choose between something about the data, which would be which data do you want to plot. You can plot the pickup or drop off. You can choose things about the visualization. These are all completely custom. You can do whatever you wanted. In this case, what you did is declare the options you wanted. So there were 3 widgets. Here you declare 3 things. These aren't actually declared as widgets. These are just declared as parameters. There is a parameter. It is called alpha. It is a magnitude, which means a value from 0 to 1. There's another parameter. It's called color map. It can be one of these color maps. There's a parameter called location. It can be either drop off or pickup. And that's not about widgets. It's just saying this is declaring something about your data. And it's also defining this function, which is given these values, what would it take to make something viewable? Well, you can make a points thing with the right location. You can you can data shade it with these options. Here's where this function gets the zoom. When you zoom, it causes an X range and Y range to be computed and passed to this function. So all this function does is consume the fact that in the browser you zoomed. And then whenever you do, it'll return the tiles with the appropriate alpha and the trips. Make sense? Okay, so this is basically the start to a dashboard. And then I did start up at one earlier here. But this is the dashboard using GPS data of a different type. This is just from OpenStreetMap. All their users took all of their phones and collected all their GPS things that all got uploaded, all got pulled together, therefore anonymized. And so this is 1 billion of their locations. I'm going to zoom in, but this 1 billion fills up my laptop here. I've got 16 gigabytes. So that's roughly at the edge of what can be done on this laptop. So while I was giving the rest of the talk, it all swapped out to disk. The 1 billion points that I'd read in earlier are all now back on my disk. So as I zoomed in here, this actually helps illustrate what Data Shader is doing. So you see that it looked like an image here. As I zoom in, you can see the underlying pixels are not updating. Well, now they are. It's triggered, looks like 7 or 8 passes, depending on how many times I stop with my mouse through the 1 billion points. So it'll catch up at some point, and then I'll be able to explore the 1 billion points interactively. So, okay, so that's now properly rendered at this resolution. And so if I pull out, you can see it re-rendering each time. Each time it does that, it's going through the entire 1 billion points. It's not smart. It doesn't know that it's only looking at Europe and can ignore the rest of the world. That's also something we're being paid to do and have not done yet. Right now it's just brute force processing power. This is based on Numba and Dask. It's using Dask to use all the cores on my laptop. It gets quite hot. It's using Numba to run this at machine code speeds. And it's basically just splittering its way through a billion points and putting every one of the points in a pixel. If they didn't land in here, they just go away. They landed in here, they increase the count, and every time I zoom, it does it again. It is totally stupid, totally brain dead, but it reveals the data. Like, this is the data, that's what's there. If I want to see what's over here, I zoom in over there, it's gonna run through it, and then that's the data. So you can't get a billion points into your browser, but you can get a rendering of a billion points to whatever resolution you have, because it doesn't matter what data is there. This is the resolution I've got, right? This is as good as it's going to get. So, okay, so hopefully that makes sense. And in this case, it's a very simple dashboard, just trying to be as simple as possible, showing you the that you can have range widgets with your plots. And this is basically the output of it. This is the output as something that needs a live Python process backed by a server. Almost everything else I showed you, if you go to pyviz.org and you click through the same notebooks that I've showed you, if it works on pyviz.org, that means it works in static HTML. And that's all based on how Bokeh works. Bokeh is written in JavaScript. It has Python ways to invoke the JavaScript. The JavaScript gets embedded into your HTML page, and then you can save it. And so anytime where the data actually is in your web browser page, you can export it, you can put it on your home page, you can email it to somebody with full interactivity. You can give a presentation like I was giving. That one does have Python backing, but even if it didn't, I could explore everything but this part. This part needs Python, right? Because the data is only in Python's process. It's iterating through, making an image, passes that over to the JavaScript, and that's what's displayed. So we kind of had the best of all worlds here, is you have Python backing when you need it, the power of Python, raw machine speed, numba to make everything as fast as possible, but that's only when you need it. If you're dealing with small data and you're willing to pre-aggregate it, subset it, or whatever, then that final result can go in your static HTML file and be passed around and be on your website and communicate. All right. That's it for this part. I'm ready for a break. I see lots of green out there. This is great. You're ready to try it yourself. While I take a little break, you can take a break too, but load up the next notebook, which is 02. And as soon as I come back from break, we'll start in with questions. If you have private, personal questions, talk to me and Jean-Luc in the break. I think the break was 5 minutes. What was it, 10? I don't know. Let me see. 5 minutes. Okay. Okay, so there's a download data step that somehow we last minute must have screwed up. There's a fix to it, but that didn't get in there. You don't actually need it. It's all right. You need it to replicate the talk I just gave you. And so you will need it if you want to go home and make things work. You have to get the data in the right location where the notebooks find it. So you'll get, if you try to run the tutorial I just gave, you'll get an error. But it's only, it's used in one other tutorial that's marked skim. So it won't matter for today. So, and don't worry about it. It's a big file. It's going to crowd everybody else's Wi-Fi. So if you don't already have it, don't worry about it. It'll be fine. You'll be able to do all the exercises. At some point, there may be one little thing, oh yeah, I forgot, that does need it. It won't matter, just skip over that. You'll see it. The one thing that file is useful for is exercising your machine. So I've got a nice machine here. It's kind of old, it's several years old, but it's a good solid machine. It's got 16 gigabytes of RAM. It handles 10 billion points, it handles 1 billion points, fine. If you want to exercise your machine and find out how much your machine can do, that's when you need the bigger files. I'm not even suggesting you download the 1 billion point one. You can. It's how to do it is in there, but you should at least try the 10 million point. I've had people who have an 8 gigabyte machine who are happy with that. I have had some that are not, depending on how they've configured their machine. I've never heard from anyone who had less than an 8 gigabyte machine. I don't know whether it would work or not. I would guess not. So I would not try it right before you're about to do something else. So in any case, you don't have to try that. We're not going to push your limits on data set size during this tutorial, unless you want to recreate what I was doing. The rest of the data set should just be there and should come with it. So, okay. So back to this. So what I showed you in that first section was about HVplot. And that's something new. Last time I got the tutorial, it didn't use HVplot. But the idea is that you can use that. The pandas interface you're familiar with, you can go off with it. The rest of the work here is all going to use the native interface of HoloViews. And it doesn't matter how you get a HoloViews object. If you got it from HVplot, great. It's a concise declarative structure that has your data, and you can work with it. If you use the HoloViews interface, it's exactly the same. It doesn't matter how you got there. If you have a HoloViews object, you can lay it out next to other HoloViews objects, you can overlay it, you can sample it, you can slice it, you can animate it, whatever you want. So the rest of it is going to focus on the native HoloViews interface. I like it much better, but I never grew up on pandas. I grew up before pandas. So my brain didn't reorganize according to the pandas way of doing it. So I'm much more comfortable with this. But if you grew up in pandas and that's your go-to tool for aggregating and sampling and slicing, great. Use HVplot. So either one is fine. It really doesn't matter. HVplot is newer, so it matters a little. It's not as well exercised as the standard HoloViews way. But in principle, it shouldn't matter. Okay, so this is tutorial 2. In this part, you are expected to follow along with it, and you're expected to do it as we do it. And if I start seeing a bunch of red go up, I'm going to say, oh, okay, sorry, what's going on? Okay, so alert me if you're trying something and it doesn't do what it does for me. It should just be the same. Okay, so tutorial 2, it's about saying the situation here you're supposed to imagine is I have data, I want to see it. In order to do that, you have to take some data, some metadata that's in your brain, and you have to give it to HoloViews. It's just a bunch of bits. You have to somehow take that data, the things that you know about the data set, and declare it in order for it to be properly visualizable. So here you'll notice we are not doing import hvplot.pandas. Instead, we're doing the HoloViews way to import. So you import HoloViews as HV, and then this line declares that you want it to be using Bokeh. You can do the same thing with Matplotlib, which you can rerun at the end with Matplotlib. I'm going to go ahead and start this running. That first notebook actually was a set of slides. It uses Rise, and it's a way to show a JavaScript package for showing your Jupyter Notebook as slides. The rest of them haven't been set up to use Rise. They can be if you feel like it, but it's a little more work. It's constrained to a certain shape of slides. So the rest of them are not slides. They're just a Jupyter Notebook. And in this case, what hv.extension Bokeh does is set up the Jupyter Notebook to generate the plots using Bokeh and show them in JavaScript. Okay, so let's start with some much simpler data frame where you can actually see all of it. Here we've got a data frame. It's got some X's and Y's. And if you just look at the data frame itself, not using HoloViews, what does it look like? It looks like a bunch of numbers. And this is a problem, right? These numbers could be anything, right? And you can't look at that and know what those numbers are. It's just numbers. That's not the way human brains work. You can't look at well, probably certain people with messed up brains go into certain fields of science and accounting and whatever, because they can look at those things and things jump out at them. Great, be an auditor or something. I'm talking to normal humans. To normal humans, it's just a column of numbers. And notice this has got 40 pairs of numbers here. And even that doesn't even fit on the screen. You really can't, you have to scroll back and forth or try to appreciate it. It's totally useless as a representation. Let's turn it into a HoloViews object. HoloViews doesn't make any assumption about the form. hvplot does because pandas did. Pandas assume if you didn't tell it, it's going to be a connected curve, a polyline. It's going to connect the dots. That's actually something pandas shouldn't legally do because pandas doesn't know whether this is a continuous function or not. It just does it. So hvplot follows the pandas interface. HoloViews is not going to show it unless you tell it what it is. Here you've declared it's a curve. That means that a curve is actually a graphical concept, but what it really means is it is something that displays as a curve. What displays as a curve? Samples from a continuous function. So there's an assumption that this set of numbers up here is a continuous function when I declare it to be a curve. And if you see what the representation is, the curve from x to y. Oh, well, that's new information too, because here we just had two columns. You and I can see that they're labeled x and y, and probably the x goes on the x-axis and the y goes on the y-axis. But that's a lot of assumption. Here we've declared this is an object. It's going to take some data. It's going to take some independent dimensions. Key dimensions is what we call them, and some value dimensions, which is their dependent dimensions. So you have to separate those. You can have any number of key dimensions, any number of value dimensions. Here there's one of each. And if you look at this object, simple curve, it's, oh, now that you can look at in 1 second and know a whole lot about that database, complete the data set. Unlike this one, right? This is useless as a representation. It's great as an algorithm that could go through this, but for a human, immediately this one shows you a lot. And the way we can get to this is just declare these 3 things that we as humans know about this data. Why do we know that? Well, we actually can look back. We know that because of how we created it. I know that this is a quadratic function where the y is computed from the x. So since I wrote that, I actually am it's quite valid for me to write this as well. It was in my head that this is a continuous function from x to y. But I didn't tell pandas that. That's the thing. I created it. I created this pandas data frame, and pandas doesn't know it is a continuous function from x to y. That information was in here, and it never made it into Python until here. Having made it into Python, now it is visualizable. It got from my brain, which is a sieve, on into the Python space, and now, forevermore, this will be visualizable as a curve. Make sense? It's not amazing, but it should be very straightforward. There's data that you have that needs to be given to the computer before the computer can do something automatically with it. So you've created this object, it's a HoloViews object, and so immediately you know that you can do crazy things like put it next to each other and have 2 of them and so on. Because it's a HoloViews object, you can do this kind of thing. And of course, it's a interactive object because we chose Bokeh. And you also saw already that it is an object that includes the actual raw data. This is not a copy of your data. This is your data. It's your data as long as it's in one of the supported formats. There's some other form. This could be a dictionary. It could be a numpy array, xarray, pandas, dask array, all sorts of supported formats. And then there are other formats that are converted into supported formats. If it's in one of the natively supported formats, it just is your data. It's not a copy. Some formats like a list of dictionaries or whatever might get converted into a numpy array or a dictionary of numpy arrays. There are certain ones that are less supported. But the typical ones that people will have their data in, like pandas, are just raw, just completely a pointer to that data. And so this is a cheap object. The actual memory cost for this object is approximately 0. It consists of precisely what you see this in representation. The fact that it's a curve, the fact that it has a string for the key dimension and a string for the value dimension. Okay, so it's a very lightweight thing. And all of the HoloViews, this is called, a curve is one example of a HoloViews element. If you go to the holoviews.org website and you look at the gallery, the reference gallery, you'll see dozens and dozens of HoloViews elements. This is one. I guess I should probably pull it up. So, holoviews.org, reference gallery. These are the various types of plots. We are not going to cover almost any of these. As you can see, there's a dearth of 3D ones. We actually do have a few 3D things under Matplotlib and Plotly backends. So those will be the Plotly ones will be interactive 3D. Matplotlib will be static 3D. But we're focusing on the Bokeh ones just to avoid having your brains go to mush. And so we can. We'll only look at a tiny subset of the things available. Okay, so all of these elements have the same way to invoke them. whatever the name of the element is, or just element in this case, which is just the base class. They have some data, and they take a lot of different options for the data, and then a list of k dimensions, the key dimensions, which is either one or a list of them. So if you have two-dimensional index data, it would be a list of 2 dimensions. And then a few things take some extra options, but it's very rare. So starting with this data option, here's just an illustration. When we did the data the first time, the data was a data frame. So this, what you looked at before, and I think almost everything you've seen so far is a pandas data frame. Here's some other options for that data. You can have a list of 2 numpy arrays. Remember, it has the curve is something from an x to a y, one dimension to another dimension. So here it's just showing you the first dimension, the key dimension, and then the value dimension. Or you can have lists, or you can have dictionaries, or you could have all these other types. It's the same thing either way. It doesn't matter. Okay. Okay, so the first exercise, let's see, lots and lots of green. So try to run this yourself. Try to say, remember, everything took the same interface, so try to feed the same approach to one of these other types. So here's what we had before. Try it out yourself with some other type. So copy that, put it here. That's going to give a curve. What happens when you put something else there? Or whatever. I haven't tried that. Just try whatever. If you open the HoloViews.org page, you'll see lots of other ones. You can try those too. But not every element is going to work. Basically, they all have the same signature, but this particular one needs at least 1 key dimension and at least 1 value dimension in order to plot anything. That's what a curve is. A spike is the same way. Area, same thing. Scatter. These are all the same fundamental dimensionality. Scatter 3D probably has no way to be plotted in Bokeh. Yep. So if you have something that's not supported by a given backend, I selected Bokeh. HoloViews supports 3D objects, Bokeh doesn't. So it just gives you the representation. This is all there is because there's no plotting support for it. But you can still work with it. You can still slice and dice and do everything you could before. It just won't be visualizable unless you've selected the Matplotlib backend that has the 3D scatter or the Plotly backend that has a 3D scatter. Yes?
Is it possible easily to change, say, to a log scale on one axis, or do you have to do that to the data before doing it?
That'll be an option. So let me go back to something visualizable. So curve, scatter, let's say. And then we'll get to that in a minute, but options, log, which is, it starts at 0, so it's not quite suitable for log access, so you're getting a helpful warning that that's not quite kosher, but you can do it. And if you want to, somewhere else I showed how to redo the ranges so that you avoid the warning. Don't show 0 if 0 is not valid. Okay. And also not valid for X, but can be done. Okay, so in general, what's happening with these options is that, we'll get to that in a second, but basically there's a class of options that HoloViews understands, and those will be supported across backends. And then there's a class of options that only the certain backends understand, and those will be passed down. And you'll get a helpful warning in some cases, but it won't die. It won't stop you from, so basically if you've supplied an option for the wrong backend, it won't affect some other backend, but you'll still get something. You'll still have your data, you'll still be able to work with it. So if you stick to only the options that are valid across backends, you can switch backends anytime you want. Otherwise, it's going to, that option won't apply to the backend where it's not defined. And we'll get to that in a minute, but basically the idea is that HoloViews keeps your data, and the metadata that describes it completely separate from your trivial options that are your whim of the day. Those are totally different. They're actually stored differently internally. And if you pickle it, you'll get that object by itself. You'll get the data separate from the options that it may apply to it. We'll see all that in just a second. This one's about the first category here, the actual semantic metadata, the descriptions of your data that you've captured from your brain and put it in there, the things that are just never not going to be true about your data, not the options. So in this case, let's capture a little bit more from your brain. Here, yeah, you call it X in the code, but what is it really? Well, here you don't know. It's just a parabola. But let's say the parabola represents horizontal distance. Well, you need to be able to capture that, right? So in this case, we're saying the variable X has a richer label associated with it. So this dimension, notice this is a tuple, not a list. So it's saying that there aren't two dimensions, X and horizontal distance, there's one dimension. It is a tuple of the Python identifier, so you can type it in as keyword and dot attribute access and so on, and a longer label that when you need to display it, use this label. And so as you can see, that makes horizontal distance come up here, and Y gets relabeled height. So this is still about your data. This is not in the caption. This is a very important point. Most plotting libraries, when you're coming to start relabeling things, that's in the controlling my plot stage. That is not true here. This is about your data. Your data is horizontal distance. The y-axis is height. That's capturing something about your data. It is not fiddling with the plot. You capture it here, you'll never need to type it again. You combine it later, you slice it, you do some segment of it, it knows that you declared it was height. So you pull out a sample of it, it'll say height, 80, because it knows that. That is not a plot option. Plot options are for the trivial stuff, just about appearance. Whereas height and horizontal distance are in no way about appearance. They're about what is this data? What does it represent to me? What did I put in? And so it's capturing that. That's why this tutorial is called annotating data. You're annotating it with stuff in your brain that needs to get in the computer so the computer behaves properly. And after it's in there, it automatically will have that label because it knows that that's the real name of it. All right, so the exercise here is pretty trivial, but it'll probably explain what's going on here. If I can spell trajectory. Okay. Trajectory.vdims. vdims was value dimensions. That was the dependent variables. It depends on your field whether you call this, actually the independent dimensions are sometimes called keys. The value dimensions are called values. That's why they're called values here. They're also called dependent variables. It depends whether you're a mathematician or a database person or whatever. There's no way to make everybody happy. So we made nobody happy. Called them vdims and kdims. So kdims, that should be what you expected, right? It was a dimension whose identifier is X, but it displays as this text. So it has one key dimension. It's a list of one thing. You see this is a list. It's always a list, even if you only give it one thing. This particular one has one key dimension and one v dimension. And the concise way to see that same information is just to print it. The brackets here, the square brackets mean it's key dimensions. Trying to think of this as a bracket when you're indexing into an operation, to a piece of data in Python. You have some data, you bracket to get into it. That's what this is meant to make you think of. And then the Y will be what you get back. Okay. Because remember this is not a plot, and I'm going to just say this over and over because it totally looks like a plotting library. HoloViews is not a plotting library. And here's another example of why that's true. If you have your simple curve, it's a declaration about the data. You can override any part of that declaration you want. If you change your mind, it's like, no, oops. In fact, it shouldn't be connected. That is totally wrong for it to be this. This is a quantum universe where the ball that was thrown only exists at certain strobe light positions. Okay, fine. You say so. You're the boss. So we're going to turn your simple curve into a scatter plot, or you can turn the simple curve into an area plot. anything like that works as long as they're the right number of dimensions. And if you've got too many dimensions, when you turn it into one, those other dimensions are just going to sit there. They'll be there, they're in the data, it doesn't hurt anything. You're only going to be able to see some of them depending on the type. Okay, so here's a bit of, try to predict what this is going to look like. So the HV.scatter trajectory, why would that be different from HV.scatter simple curve? Does anybody remember what the difference was for trajectory? Here's the definition of trajectory. Notice it's longer than the definition of simple curve, which was, oh, I already messed with it, but here it is. Okay, so what's the difference there? Where are we? Okay, so let's see, why will they look different? Trajectory, and then simple curve. Okay, the only difference is that the dimensions have been labeled, right? So it's just the simple curve has less information. It's defaulting to the identifier name, which itself defaults to X and Y. So, HV.area, trajectory. Oh yeah, by the way, there's tab completion, so area, if you don't know all the HoloViews objects, area, so that's an area. Okay, you're back to where you were before. The data just happily went along, swum along this pipeline. It's fine. Okay, this was all tabular data, columnar data arranged in columns that Pandas knows how to deal with. There are several main types of data, and we'll touch on each of the main types, but another type is gridded data, also called multidimensional, n-dimensional data. I have a more hard sciences background, so in fact, HoloViews came from a background of gridded data primarily. Columnar data came only later. We were starting with imaging data of various types in neuroscience 10 years ago or so. But so it has full support for gridded data. It's not just pandas. So in this case, this is data where there are two key dimensions. Their X and Y in this case are just completely, X is not a function of Y, Y is not a function of X. They are both key dimensions, independent dimensions, and then there's the third dimension, the value dimension. That's typical of multidimensional data. It'll have any number of key dimensions, potentially any number of value dimensions. In this case, it's got 3 total. So if you print that, you'll see it's got 2 key dimensions, 1 value dimension. That's why it's an image. Okay, and again, of course, this is interactive, whatever. This is just a useful thing, but it helps you get a color bar. If you just do .hist on just about anything, you'll get a histogram over the value dimension. Or, so in this case, there's the 1 value dimension, you get a histogram. If you want to relabel those are fine. X-axis here. Before I showed you, you took X and Y and you put a longer identifier. Here it's just changing the identifier. Sorry, putting a longer description of it. Here it's changing the actual identifier. Probably not important to worry about. So for an exercise, try it yourself. Try visualizing something. Here, I'll copy the original. Just well, you don't need to copy X and Y. They're already fine. In fact, X, Y, Y. You just need this one. So I'll copy that one. And then the thing that makes something out of it, this one. so that should be the same. You can do anything you want here, all right? I don't, whatever. You can play with it, you'll see it. Yeah?
So the gridded data looks like it assumes that it's a regular gridded data pattern.
Gridded data doesn't assume that. The image element does. There's also a quad mesh element that doesn't assume that it's, that assumes it's rectangular but not regular. It'll have different, so that was image. If you go to quad mesh, you'll see that you can have irregular sampling with a rectangular alignment. And if you don't even have that, then you need a tri-mesh. These are not entirely sorted, so somewhere in here is tri-mesh. There we go. So tri-mesh can render any arbitrary mesh, whatever it is.
All right, so it's not the fact that image can't do it, it's that it's not an image.
That's right. That's right. Each HoloViews element is a statement about certain aspects of the data, and one of the things about it, and the number of them corresponds to the number of different representations that are meaningful. An image has a certain representation that's meaningful literally as an image, like a PNG. But if your data isn't like that, you can take the same data and visualize it different ways with a quad mesh where you relax that assumption and so on. So the particular type is a statement about what you want to see out of it at the end. It isn't a plot, but it is saying this is, in fact, so image, what it means is a doubly regularly sampled continuous function of two variables. That's what an image is. Image is a lot shorter, so we say image. But really, it's not an image because it's not displayed immediately. It will be displayed someday probably, but what it really is, it's got continuous coordinate on X, continuous coordinate on Y, and the sampling is regular. That's an image, and so on. So each one of the HoloViews elements will have a similar set of semantic interpretations. It is whatever it is. An area chart is something that is a continuous value that ranges from 0 to the indicated value, and so on. Okay. So anyway, that's as much as we'll get into gridded data. We'll focus primarily on pandas because most people are from pandas background. But you can follow through the gridded tutorial. Just one little bit more in here, which is to load another data set. This particular one has more columns in it, so we can illustrate some things that we couldn't illustrate a minute ago. This particular one is economic data, GDP, unemployment, and such across different countries, across different years. So it's macroeconomic data. That's what the macro stands for. So you get a data frame. Again, it's just a bunch of columns, right? Which ones are the key dimensions? Most people here can probably figure that out, I think. If you look at this, which ones are indexes and which ones are what you measure? Which ones are what you're measuring about? That's a key dimension. I'm going to measure about Japan. That's a choice. The answer to no question was Japan. That was the question. What is the unemployment rate in Japan? So Japan is one of the variables that you have to choose. You have to choose which countries you're going to measure. You have to choose which quantities you're going to measure. The quantities you measure are going to be value dimensions. The choices you made that determine what your value dimension is are country, year. What about growth? Key or value? Value, right. You don't choose the growth, you measure the growth. You choose the country, you choose what year care about, you measure the growth, you measure the unemployment, you measure whatever capital mobility is, and you measure whatever trade is. Okay, so this has two meaningful key dimensions plus an extra one that's not meaningful, which is just the index in the array. That's another key dimension, but we're going to ignore it because it's just, they're in no particular order, so it doesn't mean anything. Okay, so country and year are good key dimensions in this data. You might look per country and collapse across year. You might look per year and collapse across country. You might keep them both. Up to you. So in this case, let's pull out one country, and then that leaves just year, right? If you have two dimensions, but you've pinned one of them to only be the United States, that's this. So the country column is always going to be United States now, so you're just going to use the year one. And so now you can look at growth per year, or growth over year. And so year is going to be your key dimension. That's the only one you have left, because you got rid of country. And we can choose whatever we want. We chose growth, and we get a growth curve. All right? So you get year and growth. Very straightforward. Okay? So, having understood that, hopefully you'll be able to do this one, which is plot the unemployment. And a good bet is copy whatever was done before. And then you're going to want to do something to that. Nonsense, right? You didn't want to do that. You can do it. You swear, how does unemployment relate to growth? Using a plot that is a continuous function made no sense at all. Keep your key dimensions and value dimensions separate. Keep year, your only thing left. It's got to be year. You can't plot anything else in this data set. So now you get to choose here. Okay. Unemployment per year. That's a meaningful plot. And it matches the type of plot you have, which is this continuous curve. Okay? Whatever you want to see, you can say that that's what the data is that you care about. Once we've created it, we can take our growth curve, which is we got right here. It's not a dead end. Remember, it's never a dead end. So if we didn't want it to have these labels, we're going to fix that. We're going to declare that growth should have a representation of GDP growth, because otherwise, what does it mean, growth? And year is just going to be year. And so now we took our object that we already created. We don't even remember how we created it. It doesn't matter. We relabel it. We can always keep working with it. We can add the units for it. Here we said it was GDP growth. We didn't say what units it was. Bad plot, bad. Got to have units. Okay, so we missed it out the first time. Doesn't matter. You can always keep adding more metadata. This is more metadata per it. Okay? In the interest of time, I won't go through this. I'll give you a couple of minutes. You can try it yourself. I'll play with it. Let's see. I won't wait for you. I'll just go ahead. So first, relabel that to time. Okay, that works. And then it needs a unit. Okay, so I'm still using the identifier year because that's the underlying identifier. I'd only changed the label of it. The label of it is time. The Python identifier is still year. That's still what's there in the data. Okay, so I'm saying, okay, this is time in years. Make sense? Okay, again, this is still not options. This is only about the data. Everything we've seen so far was only kind of brain dead, dumping some aspects of the data right onto your screen. Often you don't want to do that. The data shader plot was arguably not doing that. It was aggregating per pixel. But there are lots of ways to aggregate. And here's a way to aggregate as a histogram, which is to look at the frequency across all values of GDP growth. You create here it's using numpy to make a histogram. And then it's, by itself, that's just going to be a bunch of numbers. And then two sets of numbers. And then you pass that to HoloViews and it becomes visualizable. Of course, you can get to the data. The data is the underlying values for the bins, the locations of each bin and the height of each bin. If you take that same data, you can pass it to a function that does everything. Instead of calling numpy, You can use a different HoloViews elements that makes a different assumption, which is that it's going to compute everything. You don't have to pass it a computed histogram, you just pass it the data and it will do a kernel density estimate. That's fine too. Another way to aggregate it. Another way to aggregate it would be to take the same data and create box whiskers. Those are going to show you the mean, and the top of the box whisker shows the largest value and the smallest value. The size of the box shows you the some measure the tendency, the central part of the distribution. I don't remember whether it's 1 sigma or 2 sigmas away from the mean or something like that. And then the line will show you the average. So that's a good way to take a whole bunch of data, collapse it into something you can see. Oh, and we're illustrating options again. So in order for these, to read these things nicely, you can specify details about plotting. But this is a separate thing from specifying what you're plotting. Okay, we already looked at composing things side by side and the calls operator. We already looked at when you use plus, what you get is a layout. We already looked earlier at an overlay. Those are both containers. They're almost identical. It's just how they look. And this is an overlay of a bunch of different objects. But so the key here now is that let's say you've got this overlay and you made this great plot, but later on you want to work with some bit of that. This is what you're doing here. First you look at the layout and see how do you index into this. This is actually telling you, this representation tells you how to index into it. Layout is your object. In that object, here it's showing you the type of that object. Here it's showing you there are 4 things in the object. You can choose between layout.curve1, scatter1, area1, or spikes1. Here it just shows you the type of curve 1 is curve. The type of scatter 1 is scatter. But these are your labels that you put on it. Here it's just defaulting to the type, but you can put whatever label you want in a second. So we can select whatever we feel like. If there were 2 areas, there would be area 1 and area 2. So that's why the numbers are there, to distinguish them. Here we've plucked out the curve and the spikes. This curve and this spikes, we plucked them out and put them side by side and made a new layout. So if we print that, again, we only selected a few of them. So the idea, so again, not a dead end. You've got a plot, you can always, anything that's still there in the plot, you can grab it and do whatever you like with it, and you can still look at the data. This will probably be an error. Yep, because we didn't, the data can't be added to a plot. Okay. But you can always get the data. Okay, let's put a little bit more information in here. This whole thing here, let's say there's one version of it and another version of it. Both of them are trajectories, but one is a trajectory from a cannonball and one of them is from something else. The thing is, so this is a little bit weird about HoloViews. Basically, everything I've said till now is just provably, demonstrably correct. Nobody could argue with it. Here, it's got an arbitrary level of support for a 2-level indexing system that is useful. It is not the best, or is not the only thing you could do, but what it is that every HoloViews object has an associated group and associated label. You can just ignore the group all the time if you feel like. If it's led to the default, it won't matter. But if you want to, you can group things in a way that these are both trajectory plots, and one of them is a label of filled, so they have the same group trajectory. This particular one has a label of cannonball, and this particular one has a label of filled. Now, why is that important? It shouldn't matter, right? Why don't you just do the plot title? Well, the reason it matters is you can specify options per group. And so if you have a bunch of related plots, you can just say that they are all in the same group, and then now you can change their option. Those are all going to be red. You can make another group. Oh, those are all going to be green. You can make as many groups as you want. And it helps you, having this 2-level thing, 2 is all you kind of need because you can have any number of them. And so you can have any number of combinations of different parts of your plot that you can very easily control the options for and determine whether they normalize together, whether they lay out their colors, their properties, whatever. So in this case, Let's see. It says swap to position. You don't need to do that. That's too easy. 2 levels of dictionary style access. That's a little harder. So let's say, so cannonball. So looking at the label to layout, print. Okay, so there's a labeled layout. You can see it's got 2 things here. So let's grab trajectory. Label layout. Let's use dictionary style access instead of dot attribute. So you could do this, trajectory.cannonball. That's the easy way, but let's do it the hard way, which has no tab completion, and you have to fight IPython. Okay. Okay, what's that going to give you? Well, that's the whole thing, because those are both in group trajectory. So you were able to basically I selected the subgroup that has trajectory. They're both trajectory, so that didn't do anything. So do it again, and then cannonball. Okay. So normally we use the attribute access because it's way more convenient because you can type, and it has less syntax and you can just press tab. But if you want to do it the hard way, you can do it. And this way is important, of course, if you want to have a drop down with a widget. Do you want cannonball or filled? You can do it this way. So this way is important if you're automating things or making widgets and so on. So otherwise the same. Okay. We already talked about overlays. Okay, this will illustrate the normalization that we showed earlier. If we take, and it also illustrates, you can also change not just the options or the declarations, but also the data if you want. If you've got everything right, you just want a different set of data, you do something called clone. That gives you a copy of the HoloViews object, and you can replace anything you want. In this case, you're replacing the data. So it's, remember, these are cheap little objects. You can clone it as much as you want. You have lots of them around. Just generate 1,000 of them, no problem. They're all pointing to the same data, so they are not expensive. And so we made a copy of it that points to the same data, and then we said, oh, override the data as well. Now you have a new set of data, a new object. In this case, it's one with the same x's, but the y's are half as tall, and we're going to call that tennis ball. So we pull all those together, and now you have 3 plots, the cannonball, the tennis ball, and then the overlay of those 2. Now this is a little tricky. Notice what happens when you overlay them. Cannonball trajectory, that's because it has a group of trajectory and a label of cannonball. This is a group trajectory label of tennis ball. When you overlay them, only the group matches. So these are trajectories, and it knows that you can no longer tell the difference between these 2 things. So you get a key in different colors. That make sense? Because you overlaid 2 things and they used to have different labels and you could see them. You know which one is which. But now that you overlay them, you can no longer tell them. HoloViews knows that you just did that. And it knows that, okay, I'm going to use the default color cycle. You can change that color cycle, but by default, it's going to go through some list of colors and it's going to make them visible. Make sense? You can. I totally don't remember the options for that. We'll get to the options in a minute. There's a way to set that where you can use tabs, so if we can move that in a minute, so I can find out. But yeah, there are different legend positions inside or outside of the plot, above, below, left, right, whatever. So all the different locations. Okay, so to keep it moving, let's copy this one. We're going to, the exercise, well, it's optional. We don't need to do it, so let's not do it. That was a note to me. Okay, so I promised slicing and dicing, right? Okay, here is slicing, at least. I don't know what dicing even means, but here's slicing. So if you've got your cannonball, you can slice it, and you can slice it not in index, but in coordinates. Notice that your numbers go from 0 to 100 here, that doesn't have anything to do with how many data points you have. That's to do with the height in whatever units that was, inches, or we haven't declared the units. But if we did, it would be in some value. It might be in fractional quantities. It doesn't have anything to do with the underlying numpy array. Somewhere there is a numpy array. We don't care. We as users don't care. We want to select in all the values of Cannonball where the first dimension, the key dimension, goes from -10 to 0.5. We're going to relabel that from here to here as ascending. And if we just look at ascending by itself, we get that. If we look at descending by itself, we get that. And if we look at them overlaid, we get that. Make sense? Exactly the same thing as we were doing before, except now we've selected bits of it, and we can paste them back together. And you can see that, again, it knows that those need to be different colors, so you won't know where they are separate. Okay? And so, again, this will be selecting across whatever key dimensions you have. And here it's showing the bracket notation. You can also use a different notation called select that is sometimes, it has slightly different properties. I won't go into that, but you can't use none in this case. You can in this. Notice that we are putting these things as keywords. If it were some long thing with spaces, we couldn't do that, right? So that's why we have this separate description and identifier. So I'm supposed to remind you of that. Okay? I think that's it. So basically the whole point of this section was you've got data, turn it into something that is not a dead end, that's something you can see, but is not a dead end. Something that's visualizable immediately, but you can mix and match and slice and do whatever you want. Okay? All right. Where are we on our index? Okay. We are time for a 2-minute blitzkrieg through gridded data. I'm just going to show you this and run it, and not just so you see that it's there. You're not going to do any exercise with it, but you'll be able to see that there is such a thing as gridded data sets as well. Okay, and then you go on to an exercise. So that'll be a sort of break. Okay, so here's the data set. In particular, it's a multidimensional data set of X, Y, Z. So X, Y, Z. Well, you'll see in a second which it is. This particular one is MRI scan of a brain. Here it's converting it into an image. It's multidimensional. If you want to see it in 2 dimensions, you have to tell it, okay, I want a slice of it. And what does it do with the rest of it? Well, you get a slider for the thing that wasn't in the slice, or several slices if you want, or aggregate across. Basically, however many dimensions you have, I can't draw in hyperdimensions, but however many there are, you can slice, you can sample, you can select, you can reduce or aggregate, depending on how you think about it, and so on. Okay, so that's gridded data. Basically, whatever you can do for pandas style columnar data, you can do for gridded data, but you can do it across many key dimensions typically, and many value dimensions. So that's as much as we'll say. Okay, so now time for exercise 2. That is self-paced. That is you working. If you get into trouble, if something doesn't work the way it says it does, put your red sticker up. I'm not going to do it. I'll start it, make sure it works, but this is self-paced. And you have 10 minutes. During that time, you can ask questions if you think they're really relevant to everyone else. If not, you can talk to me personally. So, okay, tutorial 3. Customizing visual appearance, which you have to do all of the time. Even though I was saying bad things about it as trivial, you always have to do it. It's not something you're ever going to get away from. You just should never confuse customizing from actually declaring things about your data. Those are different tasks. Even though declaring things about your data does change the way it appears, they're still totally different things. Okay, so sorry about that. Now it all makes sense. Okay, so as soon as you got your data in, you're going to want to mess with it. That's the thing. And I totally skipped over the things that tell you how to do that. If you get these buttons saying that you needed to allow access, I just clicked them away reflectively, but they say something. They say something about needing access. What that means is that Bokeh needs to be able to render to a PNG. In order to render to a PNG, it does that separately in a way that needs to access the file system. So the answer is, do you want Bokeh to render off screen and save to disk? That's what you're clicking yes to. In order to do that, it's sort of a separate junior browser. So if you don't, you won't get your PNG output. That's all right. So if you don't feel comfortable clicking that button, it doesn't matter. Oh, one more thing I should do right before I go back. There was supposed to be a motivator on number 1. No, number 2. There we go. Okay, at number 2, it said we should rerun this with Matplotlib just to see. So let's do that. This is all Bokeh. Let's change that to Matplotlib and rerun the whole thing. Remember, those were all interactive plots that we got when we did all our annotating. And this hasn't been updated. So it's not supposed to be there. There are several recent changes that are not here in this release. And that fix right there is something I merged earlier. So somehow the very latest changes that make everything actually work are not in there. And I'll tell you why that change didn't work. Okay, so this is now exactly the same notebook we were going through before I went off on the gridded data tangent that had nothing to do with anything. This is the same notebook I showed you earlier, but now because we have Matplotlib backend, when you type simple curve, you get an image. Totally what you should get with Matplotlib in a browser context. It doesn't have any interactive features. It's fine, it makes an image. All the same plots should work. But what that error illustrates is that the options aren't necessarily the same, wherever that was. All these same things. This is now wherever the default Matplotlib location of the key is. It was up here for Bokeh. Whatever. And in Matplotlib, we're assuming this is for print by default, if you're using Matplotlib, because it's not interactive. And so it's helpfully labeled your subfigures for publication. You can turn that off if you don't like that. Otherwise, it's the same. And there was, well, I lost track of something somewhere, but don't worry about it. Okay, so now we need customizing. Okay, so the reason that I did that just now is that it switched between Bokeh and Matplotlib, and the reason that was okay is that I didn't specify any options that were specific to one or the other. The one thing I commented out was an option that was specific to Bokeh. Somebody put it on there, so we should make that better. If you make it better, you're customizing something that's only about Bokeh, and there are ways to do that where you declare that it's only for Bokeh, and then it doesn't matter if you switch backends. But I didn't want to get into that complexity there where you tag every option which backend it's for, because most people don't want to switch backends all the time. So I presented the simple way to do it. So bear in mind, there is a more complex way to do it where you're declaring different options per backend, and that's what you want to do if you want to support multiple backends. Most people don't want to support they just want to get their job done. So I'm not making that complex. But in this case, we'll switch back and forth between Bokeh and Matplotlib to illustrate. And we've got yet another data set. This is all about data. So in this case, it's a data set about diamonds. And the reason it's important is it has a lot of dimensions here. So when you try to visualize a lot of dimensions of the same plot, you should know that you're going to be fiddling with how to do that. And so we'll see how to do that. So if you do the simple thing, you do a scatter plot of 5,000 of these diamonds. Each one was sold at a certain value and had a certain cut and clarity and so on. You want to see what relationship there might be between the size and the price. So anybody who knows anything about diamonds knows that there ought to be some relationship there, right? The more carats, the higher the price you would expect, and that's roughly true. There are also these boundaries here in the data that are interesting, like when you can say it's a 2-carat diamond, there are a lot that are cut to be 2-carat, and very few that are cut to be 1.9 carat. It sells much better as 2, so you don't cut it as that. Maybe you make 2 smaller ones, but you don't make a 1.9 carat diamond because nobody boasts of that. So you can see that all coming out in the data. All sorts of interesting stuff. I won't talk about that. That's for somebody interested in diamonds to worry about. Okay, but let's start messing with this plot. This is an ugly plot. It's all overplotted here. You really can't see how many data points there are there. It's kind of a mess. Why is it all crammed into one little thing? Well, that's just the default so that you can lay several things out without changing their sizes. But that's not what you want here. You only have one plot, so let's stretch it out. Let's start to make this a useful plot. Okay. Suddenly you start getting into crazy stuff. Okay, what's going on here? Earlier I mentioned that I'm able to do tab completion on the options. This is how you can do tab completion on the options. Okay, this tells me all the, now I can figure out what options are available. This is all the options that are available for this particular type of scatter. So this helps you figure out all the options. It's a special IPython syntax. It is not required in any way. It's concise, and it is tab completable. That helps you not have to remember it. Otherwise, so people look at this and what is that crazy stuff? It's not Python. It is not Python, that's true. It is IPython. It doesn't have to be in the notebook. It can be, IPython can deal with it and appropriately use them, and you don't have to, it's not specific to the notebook format, it's specific to IPython. So if you launch a separate IPython process, it can handle this. Usually we don't ever do that. Usually we're either in a notebook and we use this, or we're in a standalone thing like that billion point dashboard that was pure Python, no IPython nonsense, okay? And you normally start in the notebook and move to that anyway. So you've already explored your options and literally, and then you just take them out of here and you convert it to the pure Python variant. There are ways to make the pure Python one tab completable. This is a special project for Jean-Luc, but it hasn't happened yet. It's tricky, but this works well and lets you explore the options. Okay, and so here we basically it says for any object of type scatter in this cell. This is these two parentheses percent signs mean these options apply to this cell. If I only had one, it would mean these options apply henceforth. That's not usually a good idea. You can do it if there's something you want to put it at the top of the file usually and say this applies to everything. That's fine. But usually you'll modify it per whatever's in this cell, and you say that for any object of type scatter in here, or you could even do scatter. You can do scatter.group. Those groups come and play here. They also allow you to specify which options, but I don't think we'll get into that. But basically, whatever level of detail you need to, you can always relabel things so that you can specify exactly what you want in the syntax. And here we said to change the width. We said use a y-axis. Enable hover. Oh yeah, I didn't show that. So you can see all the things that you're hovering over. And of course it's bokeh, so you can always zoom if you want to see the individual points to hover. So presumably this price axis here will vary between ideal at the top down to fair. And that makes sense, right? If for a given size, the cut is going to determine the price a good bit. In this one random sample I happened to pick, it seemed to match, so I'll go with that. I won't look any further. But you can, so those are additional value dimensions. In this case, look, we had price on our y-axis, but we also had cut. Well, cut isn't in the plot. What happened to it? Do we get a widget for it? No, because it's not a key dimension. What happens to it? Well, if we've got hover, it shows up in the plot because any number of extra dimensions can just be hover dimensions. So this lets you take arbitrarily many dimensions and do something with them. Maybe you couldn't figure out how to cram it onto this plot, but you can still hover it and find that information out. And we just use it to discover things, which is that the cut determines the price for a given carat. and so on. And I'm sure we can come up with a better plot to show that, but we just explored and found that. I've never actually done that. I just guessed it to be true. Okay, so here we have our HoloViews object. And the other advantage of this, this syntax is that it clearly separates what's about the object and the annotation about the object and what's just about how we're going to see it. Whether you see it in a log axis, well, that's your choice. Whether you have a hover tool, that's your choice. It's not about the data. What the data is not your, well, it is your statement. The data that I care about is going to be the caret, the price versus caret, and the cut versus caret. And the price is the first one, so that's the one that's going to show up in the plot because the scatter has only one such dimension by default. And then we relabel it. And these options apply. So these are the options about annotating it. These are the strictly options about modifying the appearance of it. Okay? All right, so far so good. Notice that once we've done this object here, even though that applied only to that cell, let's see here. Even though the options applied to the cell, it applied to the objects in that cell. So if I look at that same object and I don't specify any options about it down here, I get the same options I had before. So those options have become associated with this object. So this is not saying how this will appear, it's saying what options will be associated with this object. Now if that object is not displayed, those options will still be applied to it for when it later is displayed. So that notation is saying, this is how I want to see this object. Oh, maybe I don't want to see the object now, but eventually if I ever want to see the object, this is how I want to see it. That make sense? So it's all declarative, and that's what you're declaring about it in this case. Okay, and here we're taking that thing that was annotated, that had the extra information, and we're overriding some of it. So we didn't override the fact that it had hover. That's still there. We did override the size. You can keep doing it as many times as you want. This is a brand new object. This is not modify scatter doing this. It's just, there's scatter, it's still the same as it was before. This is a new object, which is why it's important that these are lightweight objects. Every time you apply a set of options, it's a new object, brand new, and you can do whatever you like, it won't hurt your original. And if you do clone, if the data, that'll copy everything. Here it's just lightweight copies of the same data, and as many pointers as you want to it, do whatever you want to them, throw it away. So it's not destroying it in any way. Okay, so if you want to use this syntax, there's your exercise. The curve above. So let's just put scatter down here. How are we going to change the height of it? Using, this was using the keyword option. This is the pure Python way, not tab completable. Here, let's use the tab completable way. Unfortunately, there's one complication that we have not fixed yet. Remember I said there are options that are applied by HoloViews, and then there are options that are passed down to the plotting library. The one downside of this particular tab completable approach is you have to know which is which. You have to know whether it's a HoloViews option or whether it goes down to the plotting library. So in this case, you're just going to have to guess. Is height a plotting option or is it a styling option? And unfortunately, the tabs completes on both of them. Why is that? It doesn't show up here. That's weird. It should only tab complete on one of them, right? There must be a plotting option of height. That's weird because normally there's no overlap, which allows this to not have to specify it up here, whether it's for HoloViews or not. So that's slightly confusing. But anyway, the parentheses just means plotting option versus, which means HoloViews option or versus underlying. So if you change these, I don't have any idea what's going to happen. Okay, I didn't think there was a height option that goes down to the back end, so I don't know why that tab completed. That is somewhat alarming. You should get an error though, which is what we did at least, so it won't hurt you for long. And you just know, okay, I need those damn brackets. Okay. All right. We need to have a syntax that makes you not have to distinguish them, because we found in practice it's very important that the code knows the difference. It is not very important if you know the difference. Don't worry about it. But it's very important that we keep them separate, because those are the ones that are across all backends. I mean, if you want to support multiple backends, it's worth knowing the difference. But as long as you're just trying to get your job done, you don't care whether Bokeh implements it, HoloViews implements it, whatever. Just get it, make it look the way you want. All right, it becomes pretty straightforward to mess with all the options this way, particularly when you can tab complete. If you can't tab complete, or you want to know more than just the name of it, then you use hv.help. Also brilliant. This is all of the style options, all of the plot options. You'll see you get more information about the plot options. Those are the ones HoloViews deals with. We'll tell you anything. We'll tell you the name, the value, the type, the bounds, whether you can mess with it or not, all these things. And then after that, we show doc strings of all of them. So you can write anything you want about the plot options. The style options, we helpfully give you a list, because we do not deal with these options. We just pass them down. These are the ones that are accepted by the current backend for the scatter object. If you've switched backends, you'll get a different list here. And that's all we tell you about them, because we don't deal with them, we just pass it right down. Now there are ways that we can parse those libraries and pull out the information and put it into the help, and I would like to do that, we just haven't done that. It's not our job, but it'd be super helpful to you guys. So we haven't pulled it out of Bokeh and pulled it out of Matplotlib. In Bokeh, it's in a discoverable format, JSON somewhere, so that should be straightforward. I don't know if there's something like that for Matplotlib, but we should be able to give you more help than this, and validation and so on. Say, oh no, you can't do that. But here it's just saying, this is all we know, ask Bokeh. If these names don't mean something to you, then you got to figure it out. Okay? Whereas we wrote all this text here, Jean-Luc and me and Philip. By the way, I should mention Philip Rudiger. He's the one who wrote most of the first version of most of these tutorials. He and I worked on most of it together. Jean-Luc has done some of them. Jean-Luc did the foundation work to all of it a long time ago. This is very much a collaborative project. Okay, so like I said earlier, you want to, if you're going to, you've got all these dimensions, if you want to get more data crammed into that plot, you're going to have to do some work. So in this case, let's say we've got, remember we kept a couple of value dimensions, cut and clarity. Cut only showed up on the hover. We kept price and price. We had one independent dimension of caret, we had price and cut. Well, earlier we had price and, it was a cut? Yeah, it was cut. So anyway, we can do more with cut, because these are dots. We can control their size and their color. Let's go ahead and map their color, the cut onto the color. And that's a good choice, it turns out, because there are 5 different cuts, and that's categorical information. Categorical information works very nicely onto a color, because we can distinguish between different colors. And so if we hover over things, you can see patterns developing. You can maybe see there's a bunch of the very goods down here. I don't know. You can explore it and so on. So anyway, color makes sense to map onto. And here we're going to choose the color map. So if we left that off, I think that might be the default. No, the default is this color set. So that's not very useful in this case, because it's categorical. So we choose a categorical color map. Better idea. And then we chose to make it somewhat transparent. And so on. Okay? Exercise. Oh, this is a tough one. Display scatter without any new options. Okay, that was hard. All right, so it's the same thing. And remember, these have been associated with that object now. And now, set the style option. Oh, this is the handy clear look. When we do this, it means fill in the options up here, so you don't have that thing happen to you that happened to me. And the styles option, we have to do it by type. And so what is the type of this thing? Scatter. A style option, that means it's not the brackets, it's the parentheses. Size equals. It works. Not too surprising. Oops, I didn't mean 110. That's what I meant. All right. You can switch any of these options that were this size option. Bokeh calls it size. Matplotlib calls it S. Okay. So if we switch the backend to Matplotlib, we get a plot, just as we did before. Now we need to use the word S instead of size. We could do a project and we could make mappings between these two backends at least. We have two main backends, Bokeh and Matplotlib. We could do it. It could be done. We could try to translate between the two conventions. We haven't. It's work. I'll skip this exercise. You can do that if you want. If you want to do what we did for Bokeh and apply them here. I don't think they're any different because I think they're spelled the same. So it's not. That was one magic. We just showed you the output line magic where we switched between backends. We can do that to also switch between different supported, completely different types of output. In particular, for Matplotlib, we can switch between PNG, the default, and SVG. And now, if you use SVG, now is when you actually get your publication quality plots. If you save your image from that, that's going to be SVG image. So I mean, it looks like it looks the same, but it's now SVG. It's got little weird markers for whatever reason. Oh, and we just did that. Okay. If you want to export, Bokeh supports exporting to PNG, and that's what you got that little checkbox for. It's to support this one cell here. It displays, this is now an image. So if we're telling it the output for figure, this means the output for static images is going to be PNG. You can also make the output for animations be GIF or GIF. I haven't done that. Yes? There is kind of annoyingly using some old syntax like this. But the new options still apply because I just reset them in the same cell. That's clearing all of the options. But we're not planning to keep this syntax forever, so it's kind of annoying that we haven't provided another syntax. Ops is a more complex way of setting the options that we're trying to deprecate now. You would do something like yeah. So, yeah. To clear? Well, you just override that one option if you want. I don't think there's a way to clear it back to the defaults. Jean-Luc, I don't know if you're in here. Is there a way to set a particular option back to its original default value? Right, but that resets everything. Could you? Okay, there is a way to do it. It's complicated. You can actually look up the default value and set it to that value. There's no easy way to say, just get rid of what I did, except to rerun your notebook. Okay. Okay, that's Bokeh PNG. And if you actually look on your disk, you're going to have a file that's PNG. Bokeh also supports SVG, but we haven't. What it does is if you have a complicated layout, it gets you a different file for each one. And that can be useful, but we haven't supported it. This Matplotlib one will give you the whole figure as an SVG. And so we're figuring that if you're, no pun intended, if you want a multi-pane figure, you're probably going to use Matplotlib to compose that, given how Bokeh generates it. But we can revisit that. Okay, like I said, I think that's the last bit of this notebook, which is using the group and label to determine how you can customize things. So in this case, We've got some more complicated plot here. We're overlaying a couple of, 4 different things. We're overlaying some dots and some spikes for no particular reason, and some other dots and some other spikes, and they each have different colors. And the reason they have different colors is that we have set the, not just per type, which would be for the spikes, but for the groups, for diamonds, and for diamonds that are grouped low. And so there are 2 categories here. We labeled these guys low. The first 2, low clarity diamonds. We must have pulled them out somewhere. Oh yeah. So we pulled out the low clarity diamonds, and we pulled out the high clarity diamonds. And now we're going to overlay it all, and we use these labels to basically send the right option down into the right thing. We could have done the same thing by editing each one and putting the options right there on that object. Doesn't matter what you do. This way is good if you're trying to do it across a whole slew of things and you want to control everything at once. Whatever. Okay, I'll leave these for your own work. Okay, now you've gotten to where you should have gotten to be able to do an exercise. You deserve a break though. So let's look at the schedule for that. But you've made it through to the other side. Basically, you can do anything in HoloViews now. If you were to, so the first, like I said at the end of the first section, that was okay. You can go off and use holoplot, HV plot. You can use that, and you don't have to worry about anything else. The same thing at this point. You come to the second checkpoint. The first checkpoint was use HV plot. Second one is now you can use holoplot, HoloViews. HV plot was briefly called holoplot till there was a trademark dispute, so it's not called that anymore. But it's HV plot. So you can use HV plot, and that's fine. If you use HoloViews, by this point in the tutorial, you now have, this is the meat of HoloViews, which is be able to take your data, wrap it up, make it visualizable, do stuff with it, and then customize how it appears. With that, you can do just about anything. Everything else is more advanced topics. So at that point, so let's give you a break. We've covered this thing in somewhat random order now, but take a 5-minute break, or you can get right into exercise 1. Either way, you'll have 15 minutes now. Break plus exercise 1. Okay, so we should get started again. Does anyone have a deep fundamental question about really why does it work this way, what is going on? Or did anyone discover something really surprising that you looked and you saw what the code did and like, whoa, what's going on there? Does anyone want to ask a question about that? Yes?
If you do the bars plot, and you pass a list instead of passing a data frame, it uses, you get 2 sort of bars back instead of a nice full distribution of it.
Pandas enforces a certain structure to the data that can be indexed in certain ways, and we make certain assumptions about the intent of whoever set up that pandas data frame, and we don't make those assumptions about lists because the list can be anything. So sometimes for the list case, you need to pass in additional metadata to match what we assumed about the pandas data frame. Like, surely you wanted that to be true because you set it up this way. As list, we don't know. So yeah, there are differences like that. They're subtle. Yes?
Can you review again the relationship between HoloViews and the JavaScript and Python?
Yes. I've got a picture of that. Where is it? This used to be part of the tutorial, and I moved it here so that everyone would see it, thereby skipping it. So, here's the diagrams showing the whole relationship of some tiny subset. Actually, first, let me show you something fun. This is PyViz. Each of the dots here is a library. We've written about 10 of these libraries, maybe. The rest are all some random person in the world. Maybe some of you guys have written these libraries. These are all showing PyViz at the top depends on each one of these things. And each one of these things depends on things. And one of these things depends on anything, right? And so this is what we deal with. When you do conda install -c PyViz, it's traversing this entire chain of dependencies and installing all this stuff. So that's what PyViz gives you. It gives you this bucket of stuff here. So we've taken some tiny bit of it and put it in this diagram. This tiny subset of it, and part of the complexity there is the geo stack. Anything to do with geo, it's just this whole bunch of legacy code all packaged on top of each other. It brings up a whole bunch of dependencies. If you don't need geo, cut that out and your graph becomes a lot simpler. If you don't need data shader, you miss some other things and so on. But here's a tiny chunk of that designed to make sense in the way that the chart I just showed you doesn't make sense. Here we're saying there are two different kinds of users. And let's say if you are a user who is not a developer, you're not a hacker, a hardcore coder, you care about your data and how to understand it. What you would do is you would take either small data or big data, put it into HoloViews. HoloViews doesn't do anything to it. It just wraps it up in a little bit and makes it something that you could do something with. And the output of HoloViews is a rich object, an object that displays itself and can do other stuff. The other stuff is all done by other libraries, though. And what happens depends on whether it's small data or big data. If it's small data, you wrap it up as HoloViews. The entire set of data gets passed into Bokeh. It gets passed into Bokeh Python. There's also a corresponding library, Bokeh.js, that is pure JavaScript. And once you give it over to Bokeh, the output of that is going to be HTML, JavaScript, CSS, that sort of thing that can be displayed directly by a browser. So you can use Bokeh with HoloViews plus Bokeh and feed it directly to get HTML and put that in your browser. And in that case, the HTML contains the JavaScript created by Bokeh in response to the Python commands generated by HoloViews. So that's one path you can take. You use HoloViews to create Bokeh Python objects. Bokeh creates from the Python objects a JavaScript object embedded in HTML and passes that to a browser and you can display it. That's one thing you can do. Or you can fire up Bokeh server. That's what that separate dashboard did. That's the JavaScript, then gets passed onto the Bokeh server, which responds to HTTP requests in your browser. Or what we've been doing almost this whole time is Bokeh to Jupyter. Bokeh gives JavaScript into Jupyter. Jupyter embeds the whole thing in a whole nasty snarl of JavaScript, and then that goes to the browser. Or if it's data shader, then you take your big data, it goes through HoloViews. Data shader turns it into images. You can either take that image and display it directly in a browser. So you don't need any JavaScript or anything. Data shader will take either via HoloViews or straight. Data shader can take data and turn it into images like PNGs, and that can go straight to it. Or data shader can do that in Jupyter, or data shader can do that and pass it into Bokeh and make it into zoomable. Bokeh will add the JavaScript on top, and then you can zoom it, and the result is a plot, where plot means JavaScript, an interactive plot. And then you can either go straight to the browser or through the server. Does that make sense? It's a mess, but these are all valid paths. These are all things you might want to do. And if you're not a data analyst and you're a developer, you might directly code in Data Shader. You might directly code with Bokeh. But in our group, at least, we try to make sure HoloViews covers the cases where you're analyzing data, and Bokeh covers the cases where you want to build something, where you're fundamentally starting out, I want to build something today. Bokeh is a great way to build stuff. One of the things you can build with it is HoloViews. If you have HoloViews, that's a great way to deal with data. So that's our basic. So you can use Bokeh by itself. Bokeh's syntax will be often very concise and nice. For other things like in HoloViews, when you put the widgets on there, doing that in Bokeh is going to be very, like pages and pages of code for things that are just a one-liner in HoloViews, because HoloViews is trying to get at what is it you're doing with your data. And if you can do it in HoloViews, you're not going to be programming, you're just going to be doing it. And whereas if you're doing it in Bokeh, you're going to be programming, you're going to be creating this architecture. But eventually, if you want it to be interactive and in a browser, it's going to be JavaScript and it's going to come from Bokeh. If you take Bokeh and replace it with Matplotlib in this picture, images will come out the other end of that box. And then we could do a similar box for all of those other things in that big, complicated dot graph. Okay, anything else? Great questions, by the way. Yes?
None of these boxes are labeled PyViz, so what is the name PyViz?
This is all PyViz. PyViz is all the stuff that we can manage together. So on the front page here, PyViz, I've zoomed in so it's messed up the things. PyViz is these things, but PyViz is this. This is PyViz, some of which we control, and the key thing that we control is HoloViews. That must be in there somewhere. we make your life make sense at the HoloViews level, and we paper over a lot of things that were like written 100 years ago, or don't know that there is such a thing as a browser, or all sorts of other things, and we paper that together into something usable at the HoloViews level. So HoloViews is the key thing that makes PyViz possible, but PyViz is HoloViews plus all of the things that make any of it actually work. HoloViews provides the experience, the user data. It's the interface between all this stuff, all these packages, and you. That's HoloViews. And PyViz is the project where we maintain, where we make all of this actually work. You install PyViz and you get all of that together. And that requires coordination between Jean-Luc as a HoloViews developer, me as so I'm primarily responsible for data shader. Jean-Luc and Philip are primarily responsible for HoloViews, the param library that does the widgets, that's our colleague Chris Ball. Bokeh is done by Brian Vandeven and Matthias Paprocki. That's a separate group also within Anaconda. And neither of us tell each other what to do. We work together to make sure that whenever there's a new Bokeh release, we make sure everything else, and we work together with the Dask maintainers, xarray maintainers, pandas maintainers, some of whom from Anaconda are in another room giving Dask and pandas tutorials right now. And so that's the great thing about Anaconda, is that so many of these things are coming under the same banner, and we're all working on these projects, and we are down the hall or we're right on the chat button, and we make them work together. Oh, you just did a new xarray release? What happened? Why did everything break? Oh, that's good. Oh, great. And we'll fix that. So we work back and forth to make everything work together. So PyViz is the coordinating project. It has a website, it has an installable package, and these are the ones that we verify all work together because we made them work together. We made them work together, we checked that they work together, and we deliver them to you as a usable package. PyViz. And we got the domain by wheedling somebody who already had it. Like, oh, okay, we're going to use this. Yes?
Can I ask a much smaller question? How did you generate that graph?
Chris Ball, the one who's doing param and, well, actually, that's another answer to the question, what is PyViz? PyViz is all these packages, plus we have all of these developer tools, and I'm not going to tell you anything about. There's a whole dozen other packages that are not even in this chart that are how we maintain all of these things to work together. And one of them is called PictDev, Python Common Tasks. And then there's a version for developers and non-developers. And there's a command in there that Chris Ball wrote that does this so that we can figure out our environments. And it gives you both a text file. He wrote it 3 days ago. So it gives you a text file in this document, in this image. And it's not ready for release. We're not telling you about all that. But we have all the things that build our websites, that build the live, the websites, everything on our website is just a notebook, and it's automatically converted into a website, published on the web, and it all builds when you tag something, all this great stuff. It's all a mess. It's all wonderful, and we're not ready to tell you about it. So it's working for us, and we need to make it better before we try to have anyone else get in on the good action. Okay? All right, another great question. That's why I was doing that, to get out of my own head for a second. Okay, so we've kind of, so in this, I've given this tutorial maybe 4 different times. It's been completely different every time. It's covering some of the materials the same, but a lot of the materials new. And so what I've noticed today is that we've actually covered a lot of things early that are done late. And so here where we said 30 minutes working with vocabulary, I just checked through. We've already covered nearly everything, and partially in response to people's questions. So I'm going to pull out a couple of things there that we haven't covered, and then make sure you're aware of those. It won't take 30 minutes, and then we can get on to some of the other things. And so, okay, so how many people have heard of tidy data? Except when I mentioned it earlier. Okay, tidy data is the opposite of wide data. In tidy data, you have if it's a columnar data set where you have columns and rows, in a tidy data set, each row is one observation. It's a very simple, of all the things that you can cram into a table, tidy data is one of those possible ways you could organize things. And it's one row equals one observation. Some key dimensions, some value dimensions, the whole row is an observation. The next row is a different observation. Like it might be one measure, if you have a scientific device, it might be a measurement at a particular time. So that row will have a timestamp and everything you measured at that timestamp. Make sense? If your data is like that, it's tidy. If it is not like that, it is not tidy. It can be extremely not like that, or it can be a little not like that. But if it is exactly like that, it's tidy. And tidy, HoloViews is built around making things super easy if it's tidy. And pandas has great ways to make things be tidy. Pandas can handle anything, but in particular, it has really good tools for making things be tidy. And just to make the difference clear, here is a wide data set. Here, these are every column here is an observation. In 1966, what was the unemployment in Canada? Well, that's a measurement about Canada. What was the unemployment in Denmark? That's a measurement about Denmark. Those are independent measurements of each other. This is not tidy data, because these were not something you could measure at one fell swoop. This is wide data. And if you pivot it around, you can turn it into tidy data, where you have only one thing per line, basically. One measurement that you can, and once you've got that, then you can pass it to almost any HoloViews objects and just plot it directly, because it knows what goes on which axis very easily. So anyway, assuming you've used your pandas foo to make things be nice and tidy. Let's say you've taken some data set. In this case, it's the data set we already covered about unemployment and such. If we take that, there's a concept in HoloViews, it's just a step above element. It's actually a base class for element. It's something that's very much like an element, like a curve, but it's not got quite enough information to be visualizable. So elements are an example of a data set, but it's a weaker assumption about it. So here's an example of something that's not directly visualizable. So we took this data frame, and we've declared that it's got some indexes. But we haven't declared how do you want to see it. So here it's a data set. It's very generic. It's indexed by country and year. Those are key dimensions, and it's got these viewable dimensions. But we haven't mapped any of them onto the screen in any way. We don't say one of them is on the x-axis of any type of plot, right? So this, usually I use print to get a representation like that. Here you can just type the name of it, because that's the only representation you've got. So the data set is a good start. If you've got a data frame, you can slap it into a data set without thinking much about it. You just got a HoloViews object that you can now work with. It's not yet visualizable. You need to do one more little thing. Here, but you can already start to work with it. You can already plug in things that you know about it, and that's the key use of it, is that you can, if you plug in things now, it doesn't matter what you choose later, how to visualize it. You've already captured that growth is GDP growth, unemployment is unemployment, and so on. So you can capture things even before you've thought about how you want to plot it. So it's a good way to sort of tame a data set. A data frame. You got a data frame, you can wrap it in a data set, put in what you know, capture it, and then think about how you want to see it later. So it's a good start. And in particular, it lets you choose all sorts of ways to slice and dice things. Here in particular, you can group it by year, let's say. You can do that group with an element, but you can do it even before you get to the element stage. So you can work with your data. That's why it's got that name. And then once you're ready to view it, then it has a handy little thing. You never have to use this, but it's handy. You could always build a HoloViews object just like we've been doing so far, hv.curve, whatever. Instead, we build hv.dataset that's not viewable, and then we use the .to method to turn it into something that is viewable. In this case, we'll turn it into a curve. And the advantage of that is that it's really flexible, and you can turn anything into anything you want, and you can group it and slice it and so on, however you like. So in this case, let's take our macro, which was a data set, remember, not visualizable but indexable. And now let's map it onto, let's map the year and unemployment onto a curve. That make sense? So we're picking out a couple of the things. It's got lots of dimensions. We're going to pick out a couple of them. The year and unemployment, and we're going to group it all by country. And that will give us this plot. Okay? So that's what I was leading up to here, showing that there's this handy to, both the idea that there's a data set and there's a to that when you get something out of it is a HoloViews object. In this case, it's actually a holomap of HoloViews objects. Every time you saw one of these things, it was actually this object called a holomap. What that is a multi-dimensional dictionary. It's a dictionary. You know how in Python dictionary you have one dimension. You've got a key and a value. A holomap is any number of keys and any number of values. So holomap is a generalization of a Python dictionary that allows you to address multidimensional data sets of however many dimensions you want. So, and it lets you work with things that you're not ready to display on screen, which is where you get these widgets. So the way to display a holomap is as a widget. But we can do other things with it. I'll just scoot ahead to that, which is that, let's say we've created a bunch of bars instead of a bunch of curves. And, oh, I haven't run this notebook. It's just whatever I ran before. Okay, so here I took off this little grid note, and so all I'm showing you is that we're starting where I was just a minute ago, which is starting with a holomap of bars plotting year, unemployment versus year. And now we can do things with it, just like I showed you in the introductory talk with HVplot. This is now with HoloViews objects. If you've got a holomap, you can tell it to give it a grid. You could tell it to, no, we don't need that. Oh, this is what 2 is a shorthand for. So just look at that and say, oh, I'd rather use 2. That's all you need to know. So you can do it, no problem. And once you have it, you can use, again, you can always show things with a holomap, but you can choose to have them as a layout. You can choose to aggregate them. I think that's it. Okay. So like I said, this didn't take 30 minutes. All right, so this was just a little bit extra on top of what we already showed you in the introductory part. Most things have now migrated towards the start of the tutorial, it turns out. And we already covered number 5. And in the interest of time, I'll skip exercise 2. It's worth doing, it's fun, it's not hard. It's the only thing that's new in it really is well, you skip the parts to do with gridded data, so just the parts with tabular data. And the .to method is in there. Right. All right, so I will very quickly list through a couple of things just to show you, and then I'll switch over to Jean-Luc, because my voice is getting tired, and he wrote this section anyway, number 8, or most of it. And then, so we've mentioned 2 types of data. There are several types of data. Tabular, and tabular can be either tidy or not. Gridded, another type is network data, and I'll just basically show you that Bokeh allows you to do interactive working with connected graphs. In HoloViews, it's a kind of a weird object that allows you to separate it into 2 sub-objects. It's inherently a pairing of nodes and edges. It's fairly straightforward. I won't go into it. You can read it and look at it. The interesting things are that there are multiple ways to lay out the graph data. This is just directly connecting it. This is connecting it with a different way to draw the curves. And then there's another one. You can use NetworkX to create this as a totally separate independent package, but we have an interface to it because it's a handy way to create all sorts of networks. And then you can create the thing with NetworkX, bring it in here, and now you've got interactive visualization where you would have a static one with the default NetworkX. Jean-Luc, can you write down that we should have a NetworkX HVplot interface? That would be fun. So you can naturally work with NetworkX objects and then just do .hvplot. Doesn't exist, but could. You can have an algorithm, for instance here you can use NetworkX force-directed layout to determine where the nodes are. And here's the starting point, but because we can easily map things onto widgets, we can use that to show how the algorithm actually works. It's quite straightforward. You can look at it later. And those were artificial graphs, but if we use something like some data about connections in a social graph in Facebook, you can plot it using the existing The positions of these were determined by a force-directed algorithm, but then things are just connected up, or we can bundle the edges so that it's, and then now you can pick each one and see who's connecting to what, and so on. So we're, at that point, with graph data, it's really hard to understand anything sort of ever, but especially if you don't have anything interactive. Interactive, at least the fact that it's just a bunch of nonsense, you can piece out one by one. Because you can see, oh, what is that node? But here it doesn't really tell you much about it, but it can tell you an arbitrary number of columns there, exactly what that node is, and then you can see all the things it connects to and so on. So graph stuff either tends to be a pretty picture that is meaningless, or it's a process where you interact with the data, and having it in Bokeh is great for that. So you can explore and understand how things relate. And it works with data shader so that you might keep the nodes in Bokeh, but because the number of connections is usually much greater than the number of nodes, you might data shade the nodes in the background, the connections in the background, so that they are only passed in as an image, so you can handle extremely large graphs that you couldn't bring in your browser. So that's it for and you can select into whatever. So that's it for graphs. Geographic data, you've already seen some examples of. I'll just mention that those are just a tiny, tiny bit of what's available for geographic data. Geographic data, the key thing is that the Earth is a globe and your screen is not. You got to do something about that. And the number of things you can do about that is infinite, and it's all a mess. And there are lots of things you can do. We support certain things, make them super easy. Standard, typical things you want to do, which is you've got something like Google Maps and you want your data on top of it. That is super easy to do, no problem. If you want to have some shapes, you can choose how everything is projected. You can dive into all the details like that. PyViz itself isn't handling any of that. It's just passing it down to the Cartopy libraries and all the libraries on which Cartopy is based. And so Proj4 and GDAL, all these venerable libraries are handling the task if you want to just show the shapes of the countries and their coastlines, and you want to put your data embedded on a map like that. That's a lot of calculation that went into that. That's all handled by other libraries. And then you can choose all the projections you want, and then in this case we're just sticking 3 points on it. But you can choose any tile source that's available. These particular ones, it's going to use a lot of Wi-Fi when I do that. Look at that, they all fill in. Good Wi-Fi here. So basically anything that's available, you can just get its URL and pass it in. You can work with shapes, you can work with GeoPandas, you can have data that's parceled out per shape, and so on. You can have multidimensional data, grids, like sampling, satellite data where it's sampling everything. You can use data shader to take very large data sets, render them in something that can be in a web browser, and then explore it graphically, and so on. We don't show that here, because you have to get the very large data set, and people don't want to do that. But it all works. Okay, so 8, that's you. And so now we're going to switch into truly deep dive, I guess. These are things that people don't need every day, but it's super important that you know that they're actually not that hard. I've showed you lots of things about zooming into one plot, which Unluck is going to say about what happens when you do stuff in that plot, and all sorts of ways that you can set it up to be custom, make everything happen, anything you want to do.
Okay, so what I'm going to talk about is essentially how you can add lots of interactivity to your plots. And it's really nice to be able to sort of hover, as you've seen already. That's just kind of built-in functionality, but you often want to have your own interactivity that you want to define yourself. So actually I'm going to go back to this tutorial that Jim just talked about, where we had these drop-down menus, and it was mentioned that these are called holomaps. So as Jim mentioned, it's like a multi-dimensional dictionary where all these extra dimensions become widgets that you can select. That was one of them, which is just this country drop-down. But we also have things like sliders. We have all these different widgets. Now, the thing about these is that, like a dictionary in Python, everything's in memory. So you have your keys, you've got your values, and if you have, let's say, 3 different sliders or 3 different drop-downs, you need a Cartesian product of all the possible number of values, and that explodes. So you can basically, if you have quite a number of different things you want to explore at the same time, you can run out of memory just by having lots of elements, all of which are using a bit of memory, and you end up with, I don't know, 10,000 or 100,000 or 1 million different elements. So this can be a problem. The nice thing about this type of thing is that you can export it to static HTML, so you can make a little web page out of it. You don't need a server or anything, and you could start browsing it. So that's the HoloMap, and there is an appendix which is all about holomaps and what I'm going to be talking about now, which is dynamic map. And there'll be some links to that in a second. So, so here, what we have is another type of thing, which is the replacement to HoloMap that's dynamic. What that means is that you write a function that returns an element, and every time you want to, like, say, change a value in a slider, what it does is it just passes in the argument to the function returns the element, and then you dynamically render it, which means that you avoid this whole problem of your memory exploding by having to have everything in memory at once, which you would do for HoloMap. So here's something called a dynamic map. And what you do is you have a callback. Here it's really, really simple. It's just an oval in a square that's rotated. It's a really simple function. All it does, it takes an angle, and it draws your oval and a bit of text, which is 0 degrees right now. And it lets you create the elements overlaid to be like a little figure here. So if you actually call this directly, I could, sorry, that's not right. I could actually just call annotations with an angle, and I'd just get a simple overlay. But by using dynamic map, I can actually pass it in this callback, and now when I move the slider, I created some custom interactivity where I can move at any angle that I want. Right? So if you imagine this was a HoloMap, then for every single angle we have here, which goes up to 360, you'd have 360 different overlays. But here we just need this little function that returns what we want to look at. So this is quite simple, and it's just a much more memory efficient way of doing like a HoloMap. So this is not too exciting because it's not something really new in terms of what you're able to do. It just saves you memory. But dynamic maps can let you do a lot more interesting things. So we have a system in HoloViews called streams. And a stream is really just a parameter. It's just a value that you can change. And when that value changes, you pass in the argument to the callback. Like, for example, the angle here could be a parameter that you want to control. And with the stream, all you do is you set that angle to a value you want, and it will just dynamically update the visualization. So, so I don't know if I'll go into detail about how you set up a stream, but it's really easy. You just import a stream, a capital stream from the streams submodule, subpackage, and you just define it. You just say it's going to be called angle, capital A, and you just initialize it with a default value of 0. So this parameter angle is just 0 right now, right? Right, so this is just showing you that we have a integer angle that start at 0. So now what we can do is we can just display our dynamic map again. It's just it's a simple container. It has a callback. You have a default value of angle 0, and it returns the overlay at angle 0, which was just that simple function above, which is just this simple box, an ellipse, and a text as an overlay. But now what I can do is now I keep a handle on this dynamic map. I can call this event method and change the angle. So it was initialized with 0, but let's say I want it to be 90. So now just watch the plot above as I hit this. I can actually dynamically change my angle to be whatever I want in a separate cell by just saying what angle I request. So it can be 45 degrees, for example, or anything I like. So this is kind of useful. It works with Matplotlib too, because it's simply just asking Matplotlib to re-render with a new angle whenever I hit the event method. Okay, so there's a little exercise. We generated initializing the angle to 15 degrees. Well, I could just copy this and then set it to be 15, and I guess that's not too interesting an exercise, so I'll actually skip that. You zoom up the event to set the angle to be 145. Well, I kind of already showed you jumping around. Oops. Not used to these key bindings. Okay, so let's say 145. Yeah, well, I see. It's got the text tell you it's now at 145. Right. So actually, I mentioned that you can use Matplotlib, so I will actually do that. So here it's still Bokeh. You can still zoom in. You can still pan around and do all the things that you can do with Bokeh. But just to demonstrate, I'm going to make this into Matplotlib, and that's what it looks like in Matplotlib. The color's changed. I don't think that's supposed to happen, but this is just a small discrepancy between the two backends. Oh, actually, yeah, that's not it. Anyway, so with Matplotlib, I can still set my different angles. I'll do it to 145 again. And with Matplotlib, you don't normally get interactivity, but using this sort of thing, you can kind of control a Matplotlib plot to be whatever you want with Python code. So let's see. Yeah, this is this exercise. We can come back to it if we have a little bit of time. Is really a simple generalization of what I just showed you. It's simply, instead of just a simple angle, you can also set the size of things. So you can set the size of your ellipse, right? So you can just imagine that it's got two parameters. Actually, yeah, I'll come back to that in a second, I think. Right, so what else do we have? We have periodic updates. Now, what does that mean? So you saw that you can set the angle and by hitting the cell, but what if you want to do a loop? What if you want to kind of dynamically change it based on some other code and you just kind of want to refresh it as rapidly as you can? So here what we have is we have, again, same thing, this little ellipse in the box starting at 0. But now what we're going to do is we're going to use this periodic method to kind of do a sweep of the angle from basically 0, which is what's initialized, to incrementing it basically every 0.01 seconds. So now what I've got is a little plot which is rotating, right? And this is all custom interactivity. This is something I decided to do for myself with my little callback, and all it is essentially a function where I've got parameters which I've decided to, which parameterize the way I'm using my elements, right? So we can hit it again. I can try to make things faster. It's recommended that you do periodic, and you could make like a for loop in Python. But the problem with that is that can be really, really fast. You queue up lots and lots of events, and your plotting system can't actually keep up. And that might cause trouble, so it's kind of recommended to use this periodic thing. So let's just try 0.01. It's about the same speed, really. That's about as fast as it can refresh. But let's just say, now I can see it much slower. So, yeah, I can edit complete. I can also stop the kernel. I might as well do that now. So just, oh, I think it's done. So the timeout is the maximum amount of time you want it to spend. So that was 8 seconds. So after 8 seconds, it's going to stop no matter what. And you can have an infinite timeout if you want it to keep going. If you've got like a visualization that you just want to keep display on a big screen, big screen that you want to always show people with some live output, for example. So this is just simple. You just increase, let's put it back to 001. You can increase the timeout, and then you can play around with it to make it do a full circle. That did 180, but I could actually make it go up to 360. Okay, so those are some very simple things of just playing around with these parameters of periodic to determine how fast you want to refresh things. Yep.
If you had a really slow function,
Yep.
take out edit can you construct that, sort of buffer it, and then it will spend half an hour constructing the object and play it?
Right. Well, you could. There are things you can do there. I think actually there's a later notebook which shows you kind of how you can push data that way. So you could pre-compute everything, and once it's all ready, you can just push it through the dynamic map, and then yeah, sure. So that's all been driven by Python code so far, where I've had this periodic method and so on. But I can do something really, really cool if I use Bokeh, because Bokeh is a JavaScript library. There's an event system in Bokeh, which lets you do all sorts of live direct interaction with your plots. And HoloViews has the support for this. And these are called linked streams, where instead of me just doing this event method and saying I want my angle to be 45 degrees or whatever, I can actually get it from the mouse, or I can get some interaction with it. So let's just have a look at that. So here, this is a dynamic interaction that I just created in a couple of lines of code, whereby, again, a very, very simple callback. It's just an ellipse, and an overlay of an ellipse, a horizontal line, an H line, and a vertical line called a V line. And they have an X and a Y value, and those are the arguments of this function. And that's what it returns. And that's just, I could call this function, so I'll actually try and do that. So I can do crosshair, and I can just say 0, 0, and that's just a simple function that returns an overlay of elements. And it could be a single element, it could be anything in HoloViews, basically, a scatter plot, a histogram, whatever you like. So let's just say 0.2. Right, so this is just a function. But because what I've done here is I've used something called streams pointer xy, which hooks into Bokeh, I'm getting my x and y value from where I'm hovering on the plot. So I now have some actual direct control over the interactivity offered by this plot. And pointer xy is just one. There's other ones we have. We have range streams. We have all sorts of different things. In the docs, you can see quite a few different examples of different ways you can just add interactivity based on Bokeh tools that you can just directly interact with the plot with. So, okay. So again, it's all the same kind of thing where you create the stream, you give it initial value. So let's just say I wanted to make my initial value 0.2, 0.2, which should mean that when I initialize the plot, it shouldn't be at the sort of center. The crosshair should be the origin. There we go. I'll just initialize it with the values I want. And now, as soon as I hover, it just snaps to my cursor. So I hope that all makes sense. So let's make a red point of size 10 that follows the cursor. This should be fairly straightforward. So what we want is a number of points. We really only want 1 point here. So what we can do is we can give it just a single point of x, y. Let's see if that works. Okay, you probably can't see it because it's probably a really small point, I think. Let's just make it bigger. There we go. Now I have a little blue point, a little blue dot, which is actually following the cursor as well. And I can make it using the option system, which was introduced. Sorry, it's this way. I can tab complete it, decide that I actually want it to be a red cursor. I can make it whatever color I want. I think purple exists. Let's see. There we go. Purple point following my cursor along with the crosshairs. So again, a very simple way of doing interactivity with HoloViews once you can just define a function that's parameterized the way you want it. Okay, that's done. So here I was talking about the different sort of linked streams we have. So pointer x would just do the x of the position of the pointer and do the y. Pointer y just does the y. Pointer xy is what we just used, which follows both coordinates. You've got taps, so you can tap on things and select things. Double tap, tap. Bounds, which is through the Bokeh select tool. Really, the best way to find out about these is to go to the website and have a look at some of the examples we have. And also to maybe look at some of the Bokeh docs and get a bit of a feel for what Bokeh offers in terms of the different tools and so on. Okay, so here's a couple of lines of code, but it's a pretty cool example, I think, where we have some stuff at the top, which is going to customize how it looks, the aesthetics. We're going to read in some data, which is about eclipses. And this is a data set about all the eclipses in the 21st century. It's got all sorts of different information about the eclipses. I got this from Wikipedia. It's got dates of the eclipses. It's got things like the magnitude of the eclipse and so on. So I'm creating a scatter. As you can see, it says h3.scatter that reads in this eclipse data. And I've chosen a key dimension of hour, which is at the local hour, local time of that position on the Earth at which the eclipse is happening, the peak eclipse. Magnitude and latitude are two virtual dimensions, value dimensions. Now here's my little callback, which returns the scatter with some text. And the text, if you look carefully, is this string that's formatted by the length of the index. And what's the index? It's just what's selected. There's another string that I have. So I'm going to show you what that does. So here's this little plot. it's got some structure to it, and that's not too surprising because you can think of orbital mechanics and how all the orbits are kind of regular. So this is showing you the magnitude of the eclipse, which is basically how much of the sun that the moon is covering, based on the local time of the position of the Earth at which it's happening. And you can see that I've also colored it, where I've colored things based on the, color index, latitude. So the color is telling me the latitude. I could have scrolled down and shown you the color bar. So the latitude goes from -90 to +90, with red as -90 and blue at +90. And you can see there's some sort of structure going on here. And where's the linked streams come in? I can actually do selections. And because I added this little text, I can see how many eclipses I've selected. So that's 134 eclipses selected. So I could do, for example, how many eclipses are between 5 a.m. and 10 a.m. local time in the next century, and it's 28. So again, there's not much code here, but you've got a pretty cool little custom visualization with not much to write. So here are some suggestions of how you could adapt it. There's lots of different things you could do, but hopefully that gives you an idea of how you can use this dynamic map to dynamically create elements, parameterized by whatever you want to change about the visualization dynamically, and then make it interactive. So I don't know how I'm doing for time. Is that okay? Though I suppose I could take some questions about that. Anyone have any questions about how you can use dynamic maps and make things interactive? Yeah. Yeah, so if we go back, you can see here in the callback, the selection example, it's got len index. Because index is actually like a list of all the points. It's a list of the index of each point that was selected. So you can actually find out which points were selected by their integer index. And here I'm just counting them. I was saying, okay, we have here in 28 eclipses that were counted. And then that's how that actually works.
Well,
yeah.
one thing
Here we go, back to the index.
Okay. So once you've got all of this, one of the things you can do with it is, again, an advanced topic, but again, people want this, they just don't want to do the work. So that would be number 9 here, operations and pipelines. And so we already introduced streams, we already introduced dynamic maps. One of the things you can do is something like this plot. I'll just sort of skip right to it, which is that you had some data. You can actually overlay multiple dynamically computed things on top of that data that are about that data. In this case, it doesn't. What it's showing here is outliers by some definition of how far a data point is from the mean. So at every time of day, this is Apple's stock over a given, it's probably just totally made up. It used to be Apple stock where we were downloading it, but then Yahoo Finance turned off the plug, and so we just made it up. So it normally was real data, but so that we could stream that in here. But anyways, the idea is that we could get this data, we can plot it, that's fine. Now we can do an operation on it where we do a rolling mean of it averaging over a certain window. Put that out here, that's the smoothed portion. We can take a rolling outlier computation based on the same window and say, give me everything larger than 1, you can control it, but by default, 1 sigma away from the mean. And so it's going to put a little dot there showing the location of that, how variable it was at that moment. So this is kind of a boring one because we created it, but if you actually took Apple from some period where there was some big announcement, there's going to be a lot of volatility at some point, and so you can use this to automatically compute a pipeline of operations on your data where you start with some data and you have a series of things that are applied to it automatically regardless of what the data is. And so often that's backwards. You start with some data, you do some stuff, and then you plot that. Here you can set those things up independently. The pipeline of operations can be set up that can apply to anything. These operations have already been defined. You can make your own operations that do anything you want and then be able to apply them to whatever data you feel like. So again, this makes good sense in the context of a dynamic map where you might have data rolling in, which is what we'll get to in just a second. So this is kind of preparatory to dealing with live streams of data. And in this case, you might have so much data that it's going to need to be data shaded. Data shader, as we showed before, that's actually an example of an operation that you can have in a pipeline. The data shade operation is something that doesn't happen when you type it. It happens when it's displayed. And so every time you zoom in, it's all based on, and so data shade is a type of dynamic map. We didn't tell you that, but it is. It's a very specific kind of dynamic map. I mean, it's one example of a dynamic map. And what it does is watch for range events. He pointed to that as one of the things you could do. When there's a range event, when the range changes, or the resolution, it needs the resolution and the range in the data. From that, it knows to create an image. And so whenever those change, it busily recomputes and shows you that dynamically as an operation in your pipeline. There could be many operations. Here's an example of data shading and applying the outlier. Actually, this is the residual, data shading the residual after the smoothing. So the difference between the smoothing and the smooth value and the actual value. So it's showing you how different it is. And then you see all of the data points that are outside. So each one of these points is an actual data point. It's not showing you the range. It's showing you everything that is larger than the sigma. So everything that's outside of it. So this blue line is a good characterization for everything except the red points. If that makes any sense? So you're getting the means. In this case, it's the residuals, but back when it was the mean, you were getting the mean plus the points that are not well characterized by the mean. Hopefully that makes sense. In your field, I'm sure you have something like that where you can take some massive data set, aggregate it in certain ways, and you often work with the aggregation, but you want to understand how the aggregation differs from the actual data and understand what you've lost from the data or what's different from the data and so on. And you can set up these custom pipelines specific to whatever it is you're doing and apply them to whatever data you get in. So once you've set up a HoloViews operation like this, it'll do that. And you can actually take this pipeline that we had above that is taking the price data, taking the rolling mean, data shading it, and then doing this thing called spreading that makes it visible. You can pull it back apart. And because this is HoloViews, everything is captured. Nothing is, you can always go back. You can peel apart the different parts of your pipeline and recombine them in other ways. So as always in HoloViews, it's encouraging you to build up stuff and reuse it over time because you can always build up other stuff out of it. Nothing is a dead end, including these pipelines and operations. So it's pretty, setting one up is not something not the first thing you're going to do, but if you work with a lot of data, you're going to want to do this to make your life easy and to give yourself power. Okay. And then one reason you're going to want to do that, like we said before, was data shader. That's why this tutorial is before this one. We don't need to go into this one because we already have discussed data shader several times. The only thing to mention is that everything we said with data shader has been a count. Data shader is actually much more general than that. It doesn't just count. It can compute any quantity when it's aggregating. It can compute standard deviation. It can compute the count is the default. It can compute means. It can compute max, min, all sorts of things you might want to do per pixel. It can do that, and you can choose that. So we won't get into that, but if you want to find out, you read that. And with, thanks to work Jean-Luc did the other day, you can now take your data shaded stuff. Bokeh didn't used to be able to hover over an image. You could hover over points or lines, all the things. You could never hover over an image, which means you couldn't hover over data shader output. Now you can, thanks to Jean-Luc. And so now you can hover and find out how many points fell in that pixel, or how many points, what's the actual standard deviation at that pixel, or whatever it is you've computed. And so, you can use color bars and so on in Bokeh, and it's all still dynamic because again, these are all things that are done on top of it. Okay, all right, so we don't need to cover that because we already did that. This part is new, and this part I'll just show you. You don't have to try it out, but it's fun. So this is streaming data. Streaming data is considered a very advanced topic. It actually is quite straightforward if you use these tools. The hardest thing is getting your head around it. Exactly what's streaming where? Okay, we already have the notion of a pipe. Here we're setting up an empty plot. So I'm not going to get too much in detail, but this is very similar to what Jean-Luc was showing. But here we set up, it's pretty similar, so it's probably not probably not that relevant. It's not the same thing, but I'll skip over that. But let's just say we wanted to make a, here we've got another empty map, and we're going to create some simulation of Brownian motion. This could be data, right now the data is coming from, this is a Python generator. The data is coming from this same Python process, but it could be coming from anywhere. You could be polling some external data source and piping it in here. In that sense, it's streaming. So this is just the general support. It's mainly illustrating some of the things that Jean-Luc was doing. The next step is if you want to make your life easy, you add in the streams library, which helps you take streams. Literally, is about streams. It's basically it's a generalization of pandas. Streams supports HVplot, so you can plot things immediately. That's not shown in here, but it does. You have to go to the HVplot website to see that. But you can have a streaming data set just as easily as you can have a pandas thing. It's all following pandas API, but for things that if you check them, they're always different. So if you use the streams library, here's where we're forcing some streams to come in. This is probably not, I probably don't want to get into that, explaining that. There's probably a better one down here that's worth explaining. Okay, this is probably a more easily visualizable, it's easy to understand what's going on here. So this, in this case, we created a stream that could easily have been polling Yahoo Finance if they had not closed it off. It can be any sort of information in the world. If you set it up as a streams data frame, a streams, actually maybe that's, I think this works. If we just, yeah, so a streams data frame is like a pandas data frame, except it's changing all the dang time. So that's the streams data frame. If you can find a way to get data into a streams data frame, everything else is easy and it just works the same as a non-streaming one. It's just that the plot just keeps on going. And then there are certain things that you might want to have it do, like be able to zoom in and not keep rolling away from you. There are ways to do that, and there are ways to make that better and so on. Those are more, we're still working on some things there. But anyway, just making something that plots. In HoloViews, basically, if you want a streaming plot, you just feed it a streaming thing, a streaming data frame rather than a regular data frame. That's really the simple story. That's what you get. And if you do that, you're going to end up with a dynamic map. Obviously, this, when you export it to HTML, is not going to be static HTML. It's not going to stream. It needs the ongoing running process. Okay, and you can stop it just the same way Jean-Luc was stopping things. It's all based on the same underlying stuff. Here's another one where this is illustrating the combination of incoming streaming thing overlaid with the pipeline. So it's a stream and its own averaging, own smoothing. And you can see that it's very straightforward to set up the object and its own rolling average, and then overlay the two. So it's all the same concepts you've been using, it's just they happen to be things that change underneath you. Other than that, it's just the same. I think that's, and you can combine your, the values and so on. And then the last, what else is there? There are all more examples of that. And of course, you can data shade it. And you can use that. There's a separate example that's a CPU monitor, let's say. That's actual streaming data coming in there because that's an external source. But this is just a GIF. Yeah, that's not running. It's a dashboard, so it's not embedded in the notebook, and I haven't fired it up. But you can build dashboards like that, interactive things that you can zoom in on that are also streaming. Okay, so streaming makes sense. You know it's there for when you need it. You'll find it. It'll be fine. It really won't be horrible. It's typically would be assumed to be. Okay, same for parameters. We've already introduced those. I'm just going to show you that those are declared. This is how they work, and you can get through. You can basically set up parameters. You can set up plots. and you can marry the two. Well, actually, you can set up parameters. You can have widgets for those parameters if you want or not. So you declare them separately. You declare that there are these parameters and that they have these properties. But you can just use that in your code. That just gives you range checking. It gives you bounds checking, type checking. Declaring the parameters is great. Everything in HoloViews is all based around the parameters, whether or not you ever see a widget for them. But if you want widgets, they're free because you've declared what your parameters are. And so you can, here, having created this object with these parameters, if we feel like it, we can show widgets for them. Totally up to you if you feel like it. And then separately, you can do so using SciPy which we don't recommend because we just have so many problems, and it also, we're always being unable to display SciPy but you can choose between SciPy and Bokeh-based widgets. Bokeh widgets you can use in a standalone dashboard. That's the great thing about Bokeh widgets. So we focus almost all of our attention and time and development effort on Bokeh widgets because they can be a notebook or non-notebook context, and they always work. Anyway, you can set things up. We already showed this in the very first part. Here what it's saying is that you can set up widgets and in the same cell control any plot you want. And you can do the same thing in the little apps that I showed you. Actually, I didn't show you the source code for the app, which is probably the last thing to show here, which is that 1 billion OSM. It doesn't need to be such a small font because it's that's all the code there is. This is the code for the 1 billion point street map data set. And so this is code that should be familiar to you by now. You import some stuff, you tell it's going to use Bokeh. You don't need a Bokeh logo because you're not in the notebook. You don't need to know that it worked. It's going to work. And then you read in the file. And this little thing tells me that I want to keep it all in memory. If I took that off, it would be paging it in from disk. It'd be very slow, but you could handle an infinitely large data set. I could also set up a Dask distributed scheduler here where I distribute it across multiple machines. I'm using the default one, which is just local machine here, because I don't need anything but this machine to handle 1 billion points. If I had 100 billion points, I would need more machines. One machine is enough for 1 billion. And then I specify the map tiles I want, a bunch of options that I felt like. I declare that there are a couple of widgets that I want. The function that is used, look, it's a stream. I didn't mention that earlier, but this is a stream object. And it's important that it's a stream because that way we get notified when something happens. Otherwise, it's just an object that has parameters. And we have a function that turns those, what we've got as a stream, which is range down here. We're going to have a range stream that whenever it changes, this function is going to be called. And when it's called, we update the tiles to the new range and the new alpha value from the widget. And then we get the plots, and then we plot it. This thing is going to give us an instance of that class. This bit is going to give us the widgets instantiating that class. This bit is going to connect the range and explorer to this function here. Don't have time to go into that. And this is going to make it work outside the notebook. So together, this adds up to that app that you saw. And you can, hopefully you can imagine, oh, I can put any widgets I want there. I'll just put new lines there. I can put any data I want. I can put any plot I want. Just use the structure. You can put anything in to make any apps you feel like. Now, that said, the app is pretty simple. We don't have a whole lot of control over where the widgets go and how it's arranged. It's going to be kind of the way it is. It is all designed to make it easy to go from things work for me in a notebook to I can share an app. It is not designed to, my app is better than any JavaScript app that people have been working on for 6 months. It is not going to go there. It is designed to get you out of the notebook and sharing with people. So we're trying to get it as easy as possible to get out of there and share it and make an impact. So that's probably let me just check the index to make sure we didn't miss anything. Yeah, so we were just discussing the deploying Bokeh apps. If you want to know how to do that, how to launch the apps, that's in there. And we already talked about that, and we're omitting that. So covered everything in some random order. Sorry for that. But thanks to Jean-Luc, and thanks to all the PyViz developers and all the people who've done bug reports and all of the people who hung out with us on Gitter and give us suggestions. It's all and all of the corporate and government sponsors who have made all of this possible, and Anaconda for letting us do it, and the Academy, and everything. Thank you.